Hey everyone, and welcome to my latest course on how to build a trading bot with ChatGPT. Okay, so I'll try to keep this brief and simple because this is designed to be a brief and simple course. The premise of this course is to answer one question. Can we use ChatGPT to build a trading bot using a pairs trading strategy? So while I have been studying finance for some time, I've never bothered to look into pairs trading myself. And I thought, since ChatGPT seems to know everything, why not use ChatGPT to build this pairs trader for me and then look at what it produces? I'll learn something new and I'll get to use ChatGPT. Now, you should be aware that this is not guaranteed to be a smooth journey. ChatGPT does make mistakes, both factual mistakes and coding mistakes, so you can't just trust everything it tells you. So you will need to apply some of our Python knowledge and some of our finance and statistics knowledge in order to get things to work. At the same time, you'll see how ChatGPT makes this process so much easier. Anyway, I had a lot of fun making this course, so I hope you enjoy it. Thanks for listening, and I'll see you in the next lecture. Okay, so in this lecture, I want to talk about the scope of this course, just so there aren't any surprises and you know what to expect to get out of this course. Okay, so the first thing I want to mention is that for this course, we are interested in pairs trading only. So we're not interested in other trading algorithms, and we're not interested in investigating what the best trading algorithm is. Okay, obviously there are many. People are inventing them every day, so we're only interested in pairs trading. And I mean, obviously, if you are interested in other algorithms, you can apply the same strategy we use in this course to look at any other algorithm you care about. Okay, so that's kind of the idea of this course. You're learning about more of a method and an approach rather than a specific algorithm, although obviously we are going to cover a specific algorithm as well. Okay, so another important point is that we're not interested in tuning the algorithm or trying to find the best pairs for you to trade. Okay, so if you're interested in finding the best pairs for your strategy, that would basically be your job, right? So you'd have to learn more about finance and statistics in order to make an informed decision yourself. Okay, so in this course, we're not interested in finding the best pairs for you. We're just interested in testing out the strategy and seeing how it works. Okay, so obviously for you personally, it depends on what market you're in, what assets you have access to, and so on and so forth. Okay, so this is an important idea. So like trend following, which we covered in my financial engineering course, pairs trading is also more of an idea and a concept rather than a specific algorithm, like say PCA. Okay, so PCA comes from machine learning or statistics, depending on your perspective, but there is only one PCA. Okay, this is unlike these trading algorithms. So in trading, there can be multiple approaches to trend following and pairs trading and so forth. Okay, so these are more concepts than specific algorithms. Okay, and so our goal in this course is only to explore what ChatGPT gives us. Okay, it's not to explore other variations, not to read books about pairs trading and incorporate that into the course. We're not interested in that. We're just interested in the specific pairs trading algorithm that ChatGPT gives us. Okay, and our goal in this course is really only to see what ChatGPT is capable of and to learn more about how it can help us be more productive and efficient. Okay, so that's the main goal of this course. Okay, so another important thing to note is that I'm not always going to check ChatGPT's output for correctness. So I will point out obvious things, but it should be clear that if you do plan to trade in the real world, you still want to do your due diligence. Okay, so one minor point is that we will not be using ChatGPT to write more code after we've generated the pairs trading algorithm to evaluate the algorithm. So we don't care about asking ChatGPT to write code to check metrics like the Sharpe ratio, Sortino ratio, or CAGR, or anything of that sort. Okay, but you can always feel free to try that yourself as an exercise. Now, as always, we have to give this standard disclaimer in finance courses. This course is not to be construed as financial advice, and if you need such advice, it is always recommended to seek assistance from a local financial advisor who is legally allowed to practice in your country or your jurisdiction. Okay, so very briefly, I'm going to go over the tools that we're going to use in this course. So I know most of you probably already know this, but just in case you don't, we have Colab, which we're going to use to run our Python code. So you can get Colab by going to colab.research.google.com. And for ChatGPT, you can go to chat.openai.com/chat. Okay, and so both of these are free, so you can sign up and start using these right away. So in this lecture, I want to give you a few quick tips in order to help you succeed in this course. Now, generally speaking, I find that when students follow these tips, they always succeed. And most often, when I see students that are not succeeding, it is because they are not following these tips. Now, I want to first mention that I truly believe that anyone can succeed in this course. This is the case whether you are a teenager still in high school or a senior who's retired and it's been decades since you've studied college math. In all cases, it really comes down to following instructions. Being diligent is key. As long as you can make a promise to yourself to be diligent and follow these guidelines, then I can promise you that you will succeed. Now that being said, what are the tips? In brief, tip number 1 is to use the Q&A. Too often, I see comments from students saying, "Oh, XYZ is missing from this course." My response is typically, "Well, actually, XYZ is covered in Lecture 5. You simply missed it." But you see, I can't tell you that if you don't ask. So what's the better outcome? You live your whole life never knowing the answer to this question, or you simply ask, maybe bruise your ego a little bit, but at the very least, improve your knowledge and skill. I prefer the outcome that results in you being better and more knowledgeable. Now, sometimes students reject this tip and say, "But I didn't know what question to ask." This is good. You are exactly who should be asking questions. The reason you don't know how to formulate your question is because you haven't thought through the subject thoroughly enough. Most of the time, what I've seen is that, in the process of trying to come up with a question, the question often answers itself. Okay, so tip number 2 is to meet the prerequisites to this course. Now, a lot of students think of prerequisites as a barrier to entry. They think, oh, if the instructor mentions the prerequisites, he's punishing me by making me do more work, and he's saying I'm dumb for not knowing this stuff. Guys, this is not true. The prerequisites are simply information which exists to help you. It's information. It's not a barrier. It's not anything to attack you. It's simply information. So how does this information help you? Well, after you have this information, if you ever see anything in this course and you think, that looks weird, I've never seen this before, at that point, it's now a good time to revisit the prerequisites to make sure that there wasn't something you missed. If you didn't have the prerequisite list, then you would have no idea where to look. But with the prerequisite list, now you have a guide that tells you what you might be missing. Okay, so now on to tip number 3. This is something I've mentioned already, but it's so important that it's worth it to repeat. Be actively involved and get your hands dirty in this course. Like, if your hands are not physically moving while you are taking this course, you are not doing this correctly. There are 2 types of lectures in this course: conceptual lectures and coding lectures. With conceptual lectures, you need to be taking handwritten notes. What I've seen myself in the past, what I've seen many other people say, and what a lot of psychological research demonstrates is that taking handwritten notes is a superior method of learning and absorbing information. This is better than staring at slides, better than watching videos passively, and better than even typing notes. Something about physically writing builds a superior mind-muscle connection. Now, when it comes to coding lectures, you already know this, but open up your favorite coding environment and write that code. If it's a course where you're learning an algorithm, then remember that implementing the algorithm is your exercise for the course. If you're just watching the lectures all the way through and twiddling your thumbs, then you are cheating by looking at the solution before completing the exercise yourself. But whether you're implementing an algorithm or just learning about a library, you must actually write code. I don't know any data scientists or machine learning engineers who don't code. Now, I just want to mention that this list is a condensed version of the full How to Succeed lecture, which can be found in the FAQ of this course. So if you have any objections to these tips or you think that they don't quite make sense, please check out that lecture for more detail. Okay, so what is the common thread between all these tips? The common thread is that the reason students don't follow these tips is because they let their egos get in the way. In fact, ego is the number one thing holding you back from succeeding in this course. Your pride is holding you back from succeeding in this course. Here's a fun fact. I've noticed a disproportionately large number of students claiming to have PhDs, but who do very poorly. Yet I see undergrads, masters, and even high school students who do better. How can this be? Well, you see, the problem with PhDs is that they think they are so smart that they have nothing left to learn. This is an example of ego and pride holding them back from learning new things. For tip number 1, ego holds people back from using the Q&A. Often, using the Q&A involves you asking a question, which reveals your mistaken assumptions, which will then be corrected by whomever answers the question. This might hurt you a little bit, knowing that you got something wrong. But as mentioned, it's better to learn that you are wrong instead of continuing to be wrong and blissfully ignorant. For tip number 2, ego holds people back from meeting the prerequisites. They think, I took calculus, therefore I know calculus, and anything that involves calculus that I see in the future, I must understand, otherwise it wasn't explained correctly. Guys, this is not a good way to go through life. I learn new things about machine learning constantly, despite the fact that I took my first machine learning course over a decade ago. And let's be clear, if you got a B or a C in your course, which is a so-called average grade, that means quantitatively, your understanding was only at 60 or 70%. Now, another common excuse I see is, oh yeah, well I took calculus 20 years ago, so I forgot everything. It's now your responsibility to teach me everything again. Guys, no, this does not count as meeting the prerequisites. Remember that the prerequisites are there to ensure you have a skill that you can make use of. It is not a list of credentials. Credentials might matter when you apply for a job, but they're irrelevant in a self-paced course when all you have to depend on is yourself. Think of it this way. Would you fly an airplane if you had a piece of paper saying that you could, but in actuality, you forgot everything about how to actually fly airplanes? I think that would be very dangerous, and I don't think that any normal person would answer yes to this question. Finally, for tip number 3, ego holds people back from getting their hands dirty and taking notes and writing code. I can tell that this is the case because when I mention how writing code is a great exercise, and it is literally the job you will do as a data scientist, people would rather argue with me than accept this advice. They care more about calling me names and making threats than they do about actually becoming better data scientists. They simply cannot handle the reality that muscle memory exists. Coding is a useful exercise, and coding is literally the job description. They would rather believe in their minds that they can write perfect code without any practice. The reason they're afraid to code is that once they start, they might make mistakes, which would expose their imperfect coding abilities. And that's the most difficult thing for someone with too much pride and too much ego. They simply cannot face the idea of being wrong or making mistakes. It's too burdensome to bear. Okay, so I hope you guys are getting the idea. Do not let your ego get in the way of your success. Don't be afraid to be wrong, and follow these instructions as diligently as possible. Thanks for listening, and I'll see you in the next lecture. So in this lecture, we are going to discuss where to get the code for this course. The code for this course mostly comes in the form of Colab notebooks. However, it is also possible for some of the code in this course to be provided in plain text Python files, which will be hosted on GitHub. So how can you tell the difference? Well, it's very simple. If you see a notebook interface on the screen, that means that code will be provided in the form of a notebook. If you see Python in a text editor, then that code will be on GitHub. Now, the main thing I want you to understand is that the notebooks are not on GitHub. Okay, so the notebooks are not on GitHub. Okay, so specifically, how can you get these resources? The answer is to simply click on the Resources tab attached to this lecture. Then, click on the link that says Code Link. This will take you to a page that contains links to every code example in this course, whether it was in the form of a notebook or a Python file hosted on GitHub. Everything is on the same page. So I want to make it clear that the notebooks should be considered as a bonus for this course. In a normal course, that is, like a college course, coding would be your homework. Now, only on this website have I seen so many students believe that it's the instructor's responsibility to complete homework for the student. To me, this is wild. So let this be a warning for those students. If you go through this course in a logical manner from start to end, and you do all the exercises as instructed, everything will make perfect sense. But if you go through this course with an attitude of entitlement, believing that you should get everything you demand and do as little work as possible, things will get difficult. I would recommend not doing this to yourself. Now, for those of you who would rather learn to code by themselves, which I always encourage, you will still need the data links for this course. As mentioned earlier, I don't want you typing data links by hand or trying to Google search the data links, which usually results in you downloading the wrong dataset. So to get the data links, simply click on the Resources tab and then click the link that says Data Links. Now, there's one mistake that many students make, even after I've mentioned it once or twice. Therefore, I found that it is necessary to mention it 3 or more times. So far, this seems to be the magic number. Okay, so what's the mistake? It's that people forget that the Colab notebooks are not on GitHub. So I repeat, the Colab notebooks are not on GitHub. And let me repeat that one more time for good measure. The Colab notebooks are not on GitHub. Okay, so hopefully that's enough to get the point across. Thanks for listening, and I'll see you in the next lecture. Okay, so in this lecture, we're going to look at pairs trading intuition. So that's pairs trading intuition. Okay, so basically this lecture is for those of you who have never heard of pairs trading before, and you want to have some idea of what we are trying to do in this course, what we are asking ChatGPT to do for us. Okay, so in order to kick off this lecture, we're going to start off with the concept of mean reversion. Okay, so what is mean reversion? So let me write that down first of all. Mean reversion. It's an ugly A. Hopefully you know what I mean. Okay, so suppose we had a stock price that looked like this. Okay, so this is time, and this is the price of the stock at time t. Okay, and it goes something like this, right? So maybe down sometimes, up sometimes, down sometimes, up sometimes, so on and so forth. Okay, so with something like this is actually really ideal for trading, because what you can do, if you know that this stock price is always going to revert back to its mean, which looks to be about here, what you can do is you can look for these points where it's really high above this mean, or really low above this mean, and you can use those points as trading signals, right? So when it's really high, that's when you want to short this stock or whatever it is, and you'll make money when it goes down. And then when it's really low below this mean value, then you would long this stock or buy the stock so that you can profit when it goes up and sell it again or go short at this top. Okay, so this is like the ideal situation, what you're looking for when you're trading. Now, unfortunately, stock prices don't really look like this. They look more like this, where they go up and down sometimes, but overall, they go up. Right? And it's really hard to predict where a stock is going to go in the future. And if you tried that, you know what I'm talking about. So, you could say, oh, of course I would sell here or go short here and then buy here, but you don't really know where these points are, especially when you can't see the future. Okay, so imagine, you're here. This is the low. You don't know it's a low. Maybe it's going to go down here. You just don't know. Or you might think it's going to go down more, so you wait, but then you wait and then it shoots back up, and then you miss this opportunity to make money. Okay, so that should give you some idea of why trading is hard. Now, back to this idea of mean reversion. What we are looking for is we're looking for two stocks. Okay, so this is where pairs trading comes into play. So imagine we have two stocks. So we've identified two stocks, and I'm going to try to draw this in colors. I don't usually use colors in these lectures, but I'll try just to make things more clear. So here's one stock, okay? And I just drew that randomly. It's where the stock goes by itself isn't really relevant. It's where the stock goes relative to the other stock. Okay, so now we have this other stock, which usually moves very close to blue, but sometimes they deviate. Okay? And so why is that useful? So imagine if we took these two stocks, so we created some new signal. So y of t is equal to, say, price 1 of t minus price 2 of t. So we're taking the difference between the two. And what happens when we do that? So now we have the difference over time. And so you can see here that in this area, they kind of move together. So, this is centered around 0. And then in this area, blue exceeds green. So the difference would be positive, let's say. And then in this area, again, they're pretty much the same. And then in this area, green exceeds blue. So the difference would be down here. And then over here, they start moving together again. Okay, so I think you're seeing the point, which is that when you combine these two signals together, it looks like a mean reverting signal. Okay, and so clearly you want to short here and long here. However, you can't short and long a difference. You have to actually short and long these particular stocks. So what would you do? So here, blue is higher than green, and you believe that these two are going to converge back together. So you short blue because you believe blue is going to go down, and you long green because you believe green is going to go up. Okay, and so the same thing applies in the second block where there's a difference. So green is higher than blue. So here you want to short green and long blue because you believe green is going to go down and blue is going to go up when they converge back together. Okay, so that's the idea behind pairs trading. Okay, so in this lecture, we're going to start looking at the ChatGPT prompts in order to get the code for our pairs trading algorithm. Okay, so you can see here that I've started with just a very simple prompt using Python, write a pairs trading algorithm. Okay, so then ChatGPT says, sure, here's a simple pairs trading algorithm in Python. Okay, so now how you proceed with this answer really depends on, I guess, the amount of experience you have, right? So I feel like if you were less experienced or you were a beginner, you'd probably just take this code and paste it into Colab Notebook or your Jupyter Notebook and then see what happens. Okay, but for me, and so I'm going to go through this course from my own perspective, obviously, because I had more experience, what I did was I started to look at the code and analyze the code, try to understand what it's doing. And I started to notice some pretty big mistakes right away. So for me, I didn't just paste this code right away into Colab Notebook to see what happens because I already know that it's wrong. Okay, so my goal in this course is to explain to you my thought process as I went through these prompts. Okay, so that is why I didn't just take this code and try to run it right away because I already knew it was wrong. Okay, so what's wrong with this code? Well, first of all, we can go through, so something nice ChatGPT does is it actually gives you an explanation of the code typically when it writes code. So it says, here's a breakdown of the code. Okay, so we load in the data for two assets, in this case stored in CSV files. So that's what that looks like. Now, you'll notice that we don't actually have these CSVs, so it's kind of imaginary right now. But you can imagine what the CSVs would look like, right? So basically, it's going to be a single column table with the price. Okay, that's what this is supposed to be. So we could make a CSV like that, but later in this course, because we really want ChatGPT to do everything, what I'm going to do is just ask it, to replace this code with actual code to get CSVs from somewhere on the internet. Okay, but this isn't really a problem. We can fix that easily. So it's the second line that was a problem. So it says, we compute the z-score for each asset, which is a standardized measure of the deviation of the asset's price from its mean. Okay, so that would be these lines. Now, here's the problem. So if you're just starting out, maybe you know some statistics, you might not see a problem with this. So you're just taking asset one, which is a Panda series, or in other words, basically a one-dimensional array containing all the time series values. And then you're subtracting the mean from all those values and then dividing by the standard deviation for all those values. And you're doing the same thing for asset one and asset two. So here's the problem with this. So I can't draw right now because I'm looking at the screen, but if I were drawing, I would draw a nice little time series. And now, you know what? We're on the internet. We can go look at a time series. Okay, so here's a time series. Now, what this algorithm is doing is it's taking this whole time series, it's taking its mean, subtracting the mean, and then dividing by the standard deviation. So what would happen with these three time series is they would be all centered around the same value, and they would be spread out the same amount. Now, here's the problem with this. So imagine, let me take this out, and let me shrink this window a little bit. Okay, so here's the time axis, and here's the price axis vertically. So suppose today is day 50, okay? What this algorithm is doing is it's taking all the days from day 0 to day 100 and dividing by the mean using all that data. But the reality is, if you're doing this for real and today is day 50, you don't have data from day 100 because today's only day 50. Okay, so you don't have data from the future from which to calculate the mean and standard deviation. Okay, so in practice, that's not how it's going to work. You have to find some other way of computing the mean and standard deviation. Okay. Okay, so other than that, we can still try to understand the other lines of this code. Okay, so the next line is the spread between Z1 and Z2, the two Z scores. Okay, so number 3, we compute the spread between the two assets by subtracting the Z score of one asset from the other. So that's basically what we did in the previous lecture when we subtracted the two prices. It's just that in the previous lecture, I was trying to simplify it for you because, prices can be on different scales and be centered around different values. But in the previous lecture, I assumed they were just on the same scale. So in reality, they can be on different scales and centered around different values. And so you'd want to compute the Z-score or do some kind of normalization to put them on the same scale so they look like what I drew in the previous lecture. Okay. And so anyway, that's the analogous of what we were doing in the previous lecture. Okay, so now that we have the spread, what are we doing? So now we're computing the rolling mean and standard deviation of the spread. Okay, and so in order to understand this, it's probably good if you've studied some finance, because then you'd know what a rolling mean is. So rolling mean and rolling standard deviation, basically it's smoothing out the time series. So if you were to, say, take this spread mean and plot it, what you would see is a similar time series to the original spread, but smoothed out. Okay, so you can try that as an exercise if you like, later on in the course. And then we have the spread standard deviation. And so what it's really doing, although it doesn't say, well, let's read what ChatGPT says it's doing. So it says, okay, we compute the rolling mean and standard deviation, and then we compute the upper and lower bounds for the spread based on the rolling mean and standard deviation. Okay, so upper and lower bound. So if you've never seen this before, if you use apps like Yahoo Finance or other charting apps that show various technical indicators, this is what we call the Bollinger Bands. Okay, the Bollinger Bands. So what is that? So basically, imagine the smoothed out, so the spread mean, so the smoothed out time series, and then you have a time series on top and a time series on the bottom, showing two standard deviations above and below the mean. Okay, and these are often used as trading signals as well. So actually, let me show you what that looks like. Okay, so here's a visual explanation of what the Bollinger Band is. So you can see here we have this smoothed out version of the time series. So the red and green bars, that's like the actual time series. This red time series is the smoothed out version. And then the green time series, both on the top and the bottom, are the mean plus 2 standard deviations and minus 2 standard deviations. Okay, and so what the concept is that if you see the price, so the actual price, touch the upper band, then you know that this is pretty high. It's higher than normal, so it's probably going to go down. So that's the point where you sell or go short. And then when you reach the bottom band, that's where you're much lower than normal. So that's the point where you buy, you go long, in order to profit when it goes back up. Okay, so that's the basic idea. Okay, so the next step is number 6. We compute the long and short signals based on whether the spread is below the lower bound or above the upper bound, respectively. Okay, and so you can see it works as I described just now. So when the spread is less than this lower bound, so the lower Bollinger Band, we set the long signal on. And when the spread is above the upper bound, we set the short signal on. Okay? And then, so remember, we can't short or long the spread, we have to actually short or long the actual stock, asset 1 and asset 2 in this case. Okay, so the next step is to set asset 1 position. That's going to be the negative of the long signal plus the short signal. And asset 2 position is the long signal minus the short signal, so the opposite. Okay, and that's also, again, what we described in the previous lecture when we were talking about pairs trading intuition. Okay, so let's go look at ChatGPT's explanation for this line. Okay, so it says, we compute the positions for each asset based on the long and short signals. Yeah, I mean, that's an okay explanation. But so what's really happening is, if you're a conscientious programmer, you might realize this is a bit strange, because here we're doing arithmetic operations, so minus and plus, and here we have a Boolean. Okay, so spread less than lower bound, well, that's going to return true or false. But you can see that we do as type int, which I believe, based on experience, is not really necessary, because in Python, essentially true is treated like 0, true is treated like 1, and false is treated like 0. So when you do arithmetic on Boolean values, you're treating true like 1 and false like 0. Okay, so it would work anyway. So basically that's what's happening. So long signal, that's going to be either 0 or 1, and short signal, that's also going to be either 0 or 1. And so notice that there are really 3 cases, right? So there's the case where the spread is less than the lower bound, but also when the spread is not less than the lower bound. And then there's the case where the spread is greater than the upper bound. And then we can also have the spread not greater than the upper bound. So really that gives us 3 areas, right? So you can be below the lower bound, you can be in between the 2 bounds, or you can be above the upper bound. Okay, and these 3 cases are actually mutually exclusive. So we can think about what values we might get here. Okay, so I just wanted to give you guys a little warning that what I'm about to say, my explanation for the trading signal, is wrong. It's actually backwards. Luckily, what I'm going to do is I'm going to think of checking it by hand, which is a good idea, because in the next lecture, we're going to discover that the trading signal is backwards. But in this lecture, I hadn't realized that yet. So just keep that in mind as you're listening to the explanation. Okay, so suppose, long signal, that might be 1. That means we are lower than the lower bound. And if it is 1, that means this must be 0, because we can't be above the upper bound at the same time as we are below the lower bound. So let's just say we are below the lower bound. Then what happens? So what this is saying is, if we are below the lower bound, that means long signal is 1. So we take -1 plus 0. Okay, so asset 1 position is -1. So does that make sense? And so that makes sense because it's saying the spread is less than the lower bound. So we're at the bottom or below the bottom Bollinger Band. So we take a short position. That's what -1 means. So we take a short position on asset 1, hoping that it'll go back up. Okay, and so asset 2 position, that's basically the opposite. Okay, so this is the second asset. And so when we are above the upper bound, then short signal becomes 1. And log signal would be 0. And so you'd have 0 minus 1, which would be -1. And you would be shorting asset 2. So that makes sense. So actually, this is kind of hard to visualize. So I might do a handwritten lecture for this to explain it afterwards, because it's kind of difficult to imagine in your mind just looking at code. So we'll do that to explain this further. In any case, let's move on to the next line. So the next line is to compute the portfolio returns. Okay, so where's that? Let's see if it tells us anything useful. We compute the portfolio returns by multiplying the asset positions by the z-scores and summing them up. Okay. So portfolio returns, so it takes asset 1 position, shifts it up by 1, multiplies it by z1. Asset 2 position, shifts it up by 1 and multiplies it by z2. Okay, so let's think about whether or not this makes sense. So, I mean, ChatGPT's explanation is kind of like a summary of what it's doing, but you really want to make sure that this is doing what it says. Okay, so what happens when you do asset 1 position shift 1? So what this does is it shifts the position signal, which is the thing from here, which is going to be either 1, 0, or -1. It shifts it up by 1. And so the reason that makes sense, and again, it's kind of hard to visualize, but just picture a table in your mind. So it shifts up all the positions by 1 date, and it gets you the return for that date. Okay, and so in fact, this is actually something that does not make sense. Okay, so Z1 is actually not the return. Z1 is the z-score for each asset. Okay, and if you know about finance, so here's a great example of, if you just pasted this in a notebook, would it work? Well, it might work, it might run, but semantically, you're doing something that doesn't make sense. Okay, so Z1 is not a return, and so therefore, this won't be the portfolio return at all. And what's interesting about this as well, so we're kind of going to be coming up against these lessons kind of sporadically throughout the course. What this means is that there's actually a lot of code out there that probably does this, right? So ChatGPT, it's just basically learned from code on the internet. And so I imagine if it's doing this, what this means is that there are a lot of people on GitHub who have done the same thing, and they don't even know that it doesn't make sense. And if you've taken my courses before, you know that I've looked at something very similar to that, which is trying to predict stock prices with LSTMs using the historical price as the input. Okay, and we've discussed at length in my other courses why that doesn't make sense. And yet that appears all over the place on GitHub and on blogs and tutorials. So you can imagine that, ChatGPT will probably pick that up as well. And if you ask ChatGPT, how do I use an LSTM to predict stock prices, it's probably going to generate something like that based on what it's seen on the internet. And if you don't know any better, you might think it's correct. And it's doubly dangerous too, because, on one hand, people are already being fooled by this, right? So in my courses, in the past few years, before, large language models even existed, people were already fooled by these things. Looking at blogs or looking at GitHub repositories and thinking that they were authoritative, but you don't really know the difference. So, and actually I should say many other courses on Udemy as well. And so people were already being fooled by that. And so now you take it a step further. People trust in AI more than they trust in some random guy's Udemy course. And so what's going to end up happening is people are going to really believe that that code is correct. Okay, and we all use signals, we all take shortcuts because we don't really have time to think things through. And so what's going to happen, the signal that you're going to use to suggest to you that what you've taken from ChatGPT is correct is that the code runs. So when you see it run, you're going to be very happy because there's no errors and there's like a little green check mark in Google Colab telling you that everything went fine. Okay, but again, this doesn't tell you about semantic errors. It only tells you about syntax errors. But again, you're going to use that signal as a shortcut in your own mind, thinking that what you got from ChatGPT is correct. Okay, so that's just something to be careful of. So in any case, we're going to have to get ChatGPT to fix this later. Okay. And so supposing that these were the returns computed correctly. So what we would need here is the return for asset 1 and the return for asset 2, which this is not, but let's suppose it was. Then you could compute the total return at the end of your trading window using some formula. Now, is this the right formula? The answer is no. But let's see what ChatGPT says about it. Okay, so it says, we compute the total returns by summing up the portfolio returns over time. Okay, so yeah, I mean, like, it looks like it's correct if you don't know anything about pandas, but this is actually not correct. And in fact, this is actually something that's going to result in a runtime error. Okay, so we would know if we ran it, but we're not going to do that yet. Okay, and again, we're going to, reiterate through these errors as we go through the subsequent lectures. So don't worry if you don't get this right away. I'm just pointing them out all right now, and then we're going to go through them again later where they will hopefully become more clear. Okay, and so that being said, the next error, well, let's see what ChatGPT says it's doing. So it says, we plot the total returns to visualize the performance of the pairs trading algorithm. Okay. So here's another mistake. Okay, so, and here you need to know a little about finance, a little bit about statistics, and a little bit about math to know that this does not work. So the cumulative sum cannot be used to compute the total return when you have returns. Okay, so returns are percentages. And it's only when you have log returns that you can compute the cumulative sum to get the cumulative return or the cumulative log return. Okay, so this is not the correct way to compute the total return of this strategy. But other than that, the plotting code is right. So the title is correct, the axes are correct. Okay, so let's see ChatGPT's conclusion to what it wrote. Note that this is a very simple pairs trading algorithm, and there are many ways to improve it. For example, you could incorporate additional factors, such as trading volume or news sentiment, or you could use machine learning algorithms to identify pairs of assets that are likely to exhibit mean reverting behavior. Okay, so that's kind of irrelevant because we didn't specify here how to choose the two assets. We just assumed that we had to. But we will be asking ChatGPT later on in this course to choose the two assets for us. Okay. Now, one other thing I wanted to mention. So you'll notice that I'm not doing these prompts live. I'm doing it as a kind of retrospective. So I've already done all my prompts and tested this out and saw what would happen. And one of the reasons I did that is because, well, one good reason is that it allowed me to think about what happened further, which is good for you because now you have the benefit of my hindsight. But also, if I were to do this again live, it wouldn't be as good because, see, right now, what you're seeing is my first thought process, right? As I went through this the first time, which is likely going to happen to you as you go through this the first time for yourself. And it might not be pairs trading, it might be some other algorithm. But you want to have a feel for what it's like to go through this without sort of poisoning the thought process by doing it twice. Okay? So that's why I'm showing you my original prompts. And the second reason, which is a more practical reason, is that my browser is actually so old it doesn't support ChatGPT. So I did this on another computer and then brought it back to this one, the one that I use to make these videos. Okay? So in any case, yeah, so basically the idea is I want to give you a sense of what it is like to talk to ChatGPT and the thought process you should go through when you're talking to ChatGPT, okay? With the benefit of hindsight, but not doing it twice so that I'm not making all the same mistakes that I did the first time, okay? So I want to include all those mistakes so that you know how to deal with them when you encounter them in the future for yourself. Okay, so in this lecture, we're going to do a little deep dive on part of the code that we saw in the previous lecture. Okay, and this is where we take the long signal and the short signal and turn that into a position on asset 1 and asset 2. Okay, and so I think the easiest way to understand this is through a very simple sort of edge case. So suppose that here's our asset 1. Okay, let's say, maybe it goes down here. Okay, and then here's asset 2, which is nothing. It's just 0. Okay, so this is technically a pairs trading strategy, except asset 2 is just 0. So really, we're just doing a Bollinger Band strategy on asset 1. Okay, and so let's say, need to use another color. Okay, let's say, here's the Bollinger Band for the top, and here's the Bollinger Band for the bottom. Okay, and so here's the Bollinger Band for the bottom. And so let me change my color back. Okay, so this is P of T, but it's also equal to our difference, which is the spread at time t since the other asset's just 0. Okay, and so the part of the code that's relevant here is, so we want when long signal so this is equal to spread less than lower bound. Okay, and short signal, this is when spread is greater than upper bound. Okay, so here we long, here we short, and otherwise we do nothing. Okay, so in these areas, long and short are both 0. Okay, and so now we can look at asset 1 position. So in the code, we said that this is going to be minus long signal plus short signal. Okay, and so the point of this lecture is to make sure that this makes sense. Oh, and I completely wrote this backwards. So this is short, and this is long. So I'm not paying attention. Okay, so asset 1 position. So in this area, short is 1, and long is 0, which means asset 1 position, we'll just say position is minus long, which is minus 0, which is 0, plus short, which is 1. Okay, so now interestingly, this seems to be backwards. So if we have minus long, it's minus 0, plus short, which is 1, we get 1. Now, here's the question. Do we actually want our position in asset 1 to be 1 in this area? And I think the answer is no. We want it to be minus 1. But let's continue anyway. So in this area, so we have long equals 1, and we have short equals 0. And this gives us position is equal to, again, minus long plus short, which is -1. Okay. So that doesn't seem to make sense at all. It really should be backwards. So I feel like this is switched around. So I think ChatGPT is wrong. This should be, I'll say should be, long minus short. I think that would make more sense. So in this case, in the first case, we'd have position equals long minus short, which is 0 minus 1, which is -1, which makes more sense. And then in the second case, we'd have position equals long minus short, which is 1 minus 0, which is 1, which makes more sense. Because you want to be 1 here so that you profit when it goes back up. And you want to be -1 here, so you profit when it goes down. Okay, so hopefully that makes sense. And so you notice that, when I first did this, I wanted to do this course like semi-live, right? So figuring stuff out as I went along. And you can see how that's happening. So while I did notice some mistakes that ChatGPT made, I didn't recognize this one, which is a pretty important one. So when I actually go through the code, I'm going to incorporate all this stuff that I figured out. And so the coding for this course will be live. Okay, so I'm not going to show you the original code, which has a lot of pointless mistakes I made. So it's going to be a little more smooth than when I did this the first time. Okay, so in this lecture, we're going to continue on looking at how we're going to fix the errors that we found in the previous lecture. So to reiterate, I just wanted to reiterate why we're not running this code yet. So for me, I'm kind of doing it the way that I saw it the first time. And so for me, I noticed all these errors before I even thought of running this. So for me, it was pointless to try to run this because I already knew there were errors. So it made more sense to fix the errors first and then run this script. Okay, so in this lecture, we're going to focus on fixing the first error. So we're not going to consider this an error, that it loads files that aren't really there, because we can fix that easily. It's this error that we want to fix. So it's using all data in a specific window, which doesn't make sense because that means for past data, you're also using data from the future to subtract the mean and divide by the standard deviation. Okay. So my prompt for that was the z-score calculation requires knowing the whole time series, but in live trading, we won't know future prices. Please rewrite the code, but using the rolling mean and standard deviation to compute on running z-score instead. Okay, so that was my prompt, but this is not the only solution. So another solution may have been to say, take the historical mean and historical standard deviation and just use that same value throughout the future window. Okay, so that's another possibility. But in any case, I decided to go with rolling mean and rolling standard deviation. And basically, if you don't know what that means, it means, so suppose today is whatever day, you're taking the last 30 days of data and computing the mean and standard deviation from that. Okay, so that's how that works. And so let's see what it did. So now we no longer have standardizing the asset 1 and asset 2, and we go straight to computing the spread. So once we compute the spread, then we do the spread mean and spread standard deviation. And notice how this was already a rolling mean and standard deviation, right? So if we look up above, that's already what it did. So somehow it knew to do that for the spread, but not for the actual assets. Okay, so in any case, notice how this is not correct. So it's trying to standardize asset 1 and asset 2 by taking the mean of the spread and the standard deviation of the spread, which doesn't make sense, right? We still want to subtract the mean of the actual asset. So asset 1 minus asset 1's mean divided by asset 1's standard deviation, and the same for asset 2. Okay, so this is also incorrect, so we'll have to get ChatGPT to fix that as well. Now, we have the upper and lower bound, so that's still correct. So it's still 2 standard deviations above and below the spread mean. Okay, long and short signal, that's still the same. Asset 1 and asset 2 position, that's still the same. But recall that, as we discovered in the previous lecture, this is actually backwards, which I didn't realize when I was talking to ChatGPT the first time. Okay, and so this stuff is still the same, but also still incorrect. Okay, so let's read what ChatGPT has to say about what it did. So it says, here's how this modified code works. So we load the data for the 2 assets, in this case stored in CSV files. We compute the spread between the 2 assets by subtracting the price of asset 2 from the price of asset 1, so that's fine. We compute the rolling mean and standard deviation of the spread over a window of 30 days, that's fine. We compute the z-score for each asset by subtracting the rolling mean of the spread from the asset's price and dividing by the rolling standard deviation of the spread. So notice how, it just says what it's doing, right? It doesn't attach any value judgment to it, which means if you are not paying attention and not looking at this critically, you will just assume that this line is the same as all the other lines. In other words, you might think it's correct. So again, this is a good lesson that you really have to apply your knowledge of statistics and coding in order to understand when ChatGPT is making these errors. Okay, so let's move on to the next line where we try to get ChatGPT to fix it again. So here we say, each asset's z-score should be computed from the asset's rolling mean and standard deviation, not the mean and standard deviation of the spread. Okay, and so ChatGPT says, you're right, apologies for the confusion. Very polite ChatGPT. Here's the updated code that computes the z-scores based on each asset's rolling mean and standard deviation. Okay, and something that's really interesting to notice is that unlike a lot of students I see, actually don't respond as well to corrections. Students actually don't like being corrected. So I guess this is one thing you can learn from ChatGPT is, if you are corrected like this, just say, you're right, apologies for the confusion. Don't try to keep convincing me that you're right, and don't let your ego get in the way. Just accept that you're wrong, accept the correction, figure out why that's the correction, and, move on and learn from it. Okay, so let's see what ChatGPT has done. Okay, so now this looks more correct. So now it's taking asset 1 and asset 2 and computing the rolling mean and rolling standard deviation of these 2 assets. Okay, and we know this is correct because it computes the spread, mean, and standard deviation in the same way. Okay, and then when we compute the z-scores, now we're using asset 1 mean, asset 1 STD, asset 2 mean, asset 2 STD. Okay, so this is correct now. I'm pretty confident that this works. Okay, so then we have the spread mean, spread STD, the same as before. Spread z-score, same as before. Upper and lower bound, same as before. So now here's something really weird about this response. And you really have to pay attention to these things because even I didn't notice this the first time. So what is the mistake? Maybe think of that as an exercise. So if you want to pause the video and try to figure out what's wrong with this, that wasn't wrong before, please do so. Otherwise, I'm going to skip straight to the answer right now. Okay, so what has changed? This line has changed. So you notice that now when we compute the long signal and short signal, we're not checking against the upper and lower bound anymore, the Bollinger Bands. Now we're just saying less than -1 or greater than +1, which it doesn't not make sense. It could make sense. It just means that you're setting your trading signals to be more sensitive and constant. But I think because we're computing the upper and lower bound, we might as well use those and stick to the Bollinger Band strategy. Okay, so let's talk a little bit about why this kind of does make sense and maybe where ChatGPT got this from. Okay, so why -1 and +1 instead of upper and lower bound, which are actually time series. So they're changing over time, whereas -1 and +1 are obviously not changing over time. Okay, and so the intuition behind this is that the z-score, as you recall, I really hate this term, by the way, z-score. Really what it is, it's just a standardized value of this time series. And people really use z-score for a standardized value of anything. So even a non-time series, just a regular feature, you'd call that a z-score if you standardized it. But I really don't like to think of it as a score. It's just a standardized value. Right? So in this case, it's the standardized time series. So you subtracted the mean divided by the standard deviation, meaning that if this were the true mean and the true standard deviation, then this would have mean 0 and variance 1. Okay, so obviously we know that's approximate because we have a time series which is non-stationary. It's changing over time. Okay, so technically the mean is not exactly 0 and the variance is not exactly 1, but this is approximate. And so because it's approximate, we can think of the variance as approximately 1, which means the standard deviation, which is the square root of the variance, is also approximately 1, which means we're basically saying if you're below 1 standard deviation from the mean, then go long, and if you're above 1 standard deviation from the mean, then go short. Okay, so basically it's the same as the Bollinger Band strategy, except instead of 2 standard deviations, we're saying 1 standard deviation. And this is more static, whereas this is more dynamic because it's using the time series of the upper bound and lower bound. Okay, but other than that, everything remains the same. Okay, so let's actually see what ChatGPT says it did in this change. So it says, we compute the long and short signals based on whether the spread z-score is below -1 or above +1 respectively. Okay, so it doesn't know that it changed it. It just changed it because, what ChatGPT generates is random. So again, this is a lesson that you really have to look out for these things. Okay, so in this lecture, we're going to continue on getting ChatGPT to fix the errors we previously found. And so just to reiterate, when I ran this the first time, I didn't catch all the errors. So I'm actually catching errors live as I look at this with you. And so throughout these prompts, we're going to see some errors remain. Okay, so in any case, the next error that we're going to deal with is how it computes the returns, right? So if we were to do this in order, right, of all the actual errors, what we would have fixed, well, we probably would have fixed this to change it back to upper and lower bound, but I didn't notice this the first time. And we also would have fixed this, which is that the asset 1 and asset 2 positions are backwards, which I also didn't notice the first time. So what I was focusing on when I first saw this, because this is a more glaring error, in my opinion, is that you're trying to compute the returns, but these are not even returns. So it's just a weighted average of the normalized asset prices. Okay, so this is not even a return. And so the prompt I used was, should the portfolio returns be based on the returns of the asset rather than the z-score? Okay, and so again, ChatGPT, very polite, says, yes, you're correct. The portfolio returns should be based on the actual returns of the assets rather than their z-scores. Here's the updated code. Okay, so again, students, if you are not taking corrections like this, yes, you're correct. then, this is something you might learn from ChatGPT. Okay, so let's scroll down and see what it did. Okay, so notice how it kept this, how it computed the long and short signals. So unfortunately, we're stuck with that for now. And let's see how it now computes the returns. Okay, so it says asset 1 returns equals asset 1 dot percent change, asset 2 returns equals asset 2% change. Okay, so just in case you don't know how this works, we will be doing a little handwritten lecture just to explain how returns are calculated, how to compute cumulative returns, and so forth. Okay, so now this is correct. So portfolio returns is asset 1 position times asset 1 returns plus asset 2 position times asset 2 returns. And so we're also going to go through another lecture to explain why this works. So, this is non-trivial in my opinion. You can't really understand this just by looking at code. You really have to draw it out and make sure it works. And, if it's an error, we might figure out that there's a bug here as well. But from what I can see, it seems correct. Okay, so we shift asset 1 position up 1 date and then compute the return based on that. And really, this is an approximation, right? So when you're actually trading, you really have the whole day to trade, right? From sometime in the morning to sometime in the afternoon, you can trade in that period. And the price is obviously fluctuating within that time period. But what we do in these simulations is we typically assume that you trade at most once per day because we have daily data. And we're usually looking at the close price or the adjusted close, which is also an approximation, which accounts for dividends. So just keep that in mind, is that these are all approximations, and we're only using the close price, which is the price at the end of the day. So we're assuming that you always trade at the end of the day and any of your profits are computed using the price at the end of the day. Okay, so let's see what ChatGPT says about what it's done. So it says the main change is in the computation of the portfolio returns in the last step. Instead of multiplying the asset positions by their z-scores, we compute the daily returns of each asset using the percent change method, and then multiply them by their respective positions. We then sum up the returns to get the portfolio returns. This way, we're taking into account the actual returns of each asset, rather than just their deviations from their rolling means. Okay, so that makes sense. And so, by the way, this is pretty amazing that ChatGPT can do this, right? Just think about where you were last year. This wouldn't be possible at all. So just take a step back to appreciate how amazing this is, that ChatGPT is able to correct itself just based on what I said, in the English language. And it's able to update this code to reflect the change that I requested. So that's pretty amazing, even if it does make mistakes sometimes. What ChatGPT is doing is, unprecedented in terms of our technology. So that's pretty amazing. Okay, so in this lecture, we're going to continue on with getting ChatGPT to fix its mistakes. Okay, so the last mistake we got it to fix was computing the portfolio returns. And so I noted in our first lecture talking to ChatGPT that the next error I noticed was that it was not computing the total returns correctly. Okay, so the problem is when you have returns as percentages, the total return is not the sum, okay? And in fact, there's two mistakes here because there's no point of running this line. And this mistake is that it's trying to compute the cumulative sum, which means that each time point, compute the return so far. And so if we're lucky, if we made money, the plot should be going upwards. This plot of the cumulative sum of the returns should be going upwards. Now, the problem is this is not even the correct computation. Okay, so there are two ways we can approach this. So the first way is if you do have percent returns, what you can do if you want to compute the cumulative return is to use the gross return. And so that is kind of hard to explain in language. It's easier to explain just writing down the equations. And the other way to solve this is to not use percent returns, but log returns. So when you use log returns, it turns out that the cumulative return is the cumulative sum. Okay, so either way is fine, as long as you remain consistent. Okay, so now admittedly, I could have phrased this better, but I was just doing this on the fly. So I said, and luckily ChatGPT understood me, which is nice. So I said, is it not the case that only log returns can be summed? Okay, so not the best formatted prompt, but ChatGPT still knew what I meant. So what did it say? So it says, yes, you're right. When calculating the total returns of a portfolio, it's generally better to use the logarithmic returns instead of the simple returns. This is because the logarithmic returns are additive, whereas the simple returns are not. When you add the logarithmic returns of different time periods together, you get the total logarithmic return, which is equivalent to the logarithm of the final price divided by the initial price. Okay, so yes, but I'd say that this is not completely correct to say that it's generally better, because it doesn't acknowledge that what it was doing before was actually not correct at all. So it's not better in the sense that one was okay and then this one's better. It's that this one is right and the other one was wrong. And the wrong one, you don't want to do that at all. Okay, so continuing on, it says, to use logarithmic returns in the pairs trading algorithm, you can replace the percent change method with the log method. Kind of, yeah. So here's the updated code. So this explanation is not correct, but the code will be correct in the way that it computes the log return. So let's have a look at that. Okay, and so you can see here, it says asset 1 log returns is equal to the log of asset 1 divided by asset 1 shifted up 1 period. Okay, so that might take some explanation, so we'll do that in another lecture, in a handwritten lecture. But in any case, yes, this is correct. Now, one alternative that would have been maybe slightly better is when you compute the log returns. So you'll recall from your math studies that when you take the log of a ratio, that's just the log of this minus the log of this. And it turns out that subtraction and addition are more numerically stable than division. So I would have personally done log of asset 1 minus log of asset 1 shifted. Okay, that would be my preference. But in any case, there's nothing wrong with this computation. It is mathematically correct. Okay, so in any case, the next step is to compute the portfolio log returns. So notice how it also, updates the variable names accordingly. Okay, so now this is correct. And now this part is also correct. Okay, so the cumulative sum does give you the return so far. Now, this line, I didn't realize this at the time because I wasn't really paying attention that much. I was paying more attention to the mathematical mistakes than the syntax mistakes. But this is a mistake. It won't run. Okay? Because if you think about it, asset 1 and asset 2 and their positions should be pandas series, right? So they should be one-dimensional. So when you compute the log return, which is the weighted sum of those series, it's going to still be one-dimensional. And these are one-dimensional as well, the returns themselves. So it's a 1D array times a 1D array plus a 1D array times a 1D array. So that's still a 1D array. So when you do this sum on axis 1, it doesn't even have an axis 1. And if it did have an axis 1, the axis 1 would be the columns, but there's only one column. So nothing about this line makes sense. So in any case, let's finish reading what ChatGPT says. So it says, the main change is in the computation of the portfolio returns in the last step. Instead of using the percent change method, we compute the logarithmic returns of each asset using the np.log function, and then multiply them by their respective positions. We then sum up the logarithmic returns to get the total logarithmic returns. This way, we're taking into account the additive nature of the logarithmic returns. Okay, so, generally correct. But again, I think ChatGPT is missing the point that it's fixing something that was previously incorrect. Okay, so this lecture is going to be a bit of a theory lecture about returns and log returns. Returns and log returns. And also, cumulative returns, how to compute the performance of our algorithm. Okay, now firstly, notice that in this course, we're only interested in how much money we make. Okay, so this is the only metric we're going to look at. Like, how much money do we end up with at the end of our trading strategy? Okay, so if you've taken my finance course or you've studied finance elsewhere, you know that there are more sophisticated methods of measuring your trading performance. For example, the Sharpe ratio, max drawdown, and so forth. And if you're interested in those, you can check out my financial engineering course, which covers some stuff like the Sharpe ratio. And, I guess just to give you a little bit of an idea why we like the Sharpe ratio is the Sharpe ratio is equal to the return of the strategy minus the risk-free rate divided by the standard deviation of the strategy. Okay, so the standard deviation of your daily returns. Okay, so why does that make sense? Is because we generally don't like if your profit or your loss, well, how much money you have, fluctuates wildly, right? We want to see something like this, something that just goes up constantly. We don't want to see something like this where it, drops by like 50% and then goes back up. That's not a nice moment when you're looking at your portfolio. Okay, so in any case, we're just going to look at how much money we make. And in order to do that, the relevant quantity is the return. Okay, so let's start by talking about, what is a return? So the return is basically the percentage of money you made relative to the amount of money you started with. Okay, and generally we compute the daily return. So how much money did you make today compared to yesterday? Okay, so the return at time t is equal to the price at time t minus the previous price at time t minus 1, divided by the price at time t minus 1, the old price. So as an example of that, suppose you started with $100 and then you ended up with $120 the next day. So what's your return? Your return is 120 minus 100 divided by 100, which is 20 over 100, which is 20%. Okay, so that's how we compute the return. Now, there's another quantity of interest, which is the gross return, which we don't really have a symbol for. So we'll call this one the simple return. And I typically don't see a symbol for gross return. But let's take this equation and let's simplify it a bit. So R of t is equal to P of t over P of t minus 1. And then we have P of t minus 1 over P of t minus 1, which is just 1 because they're the same thing. So P of t minus 1 minus 1. So the gross return is 1 plus R of t, which is just equal to, that's basically taking the 1 to the other side, is just the ratio of the new price over the old price. Okay, so this is useful because it's a multiplier. Okay, so using the same example as above, the gross return would be 120 over 100, which is 1.2. Okay, so it tells us that our money was multiplied by 1.2, and that's how we got our new amount. Okay, so using these quantities, how can we compute the amount of money we've made throughout, the whole duration we are running our strategy? Okay, so basically that's going to be, say our strategy runs from time t equals 1 up to big T. Okay, so we want to know what is the, well, let's start from 0. So we want to know the difference, or some kind of measurement of the difference between the price at time t and the price at time 0. Okay. Okay, and so there are a couple ways to do this, right? So again, we could look at the gross return. So the gross return would just be P of big T over P of 0. Or we could look at, just the simple return, which would be P of T minus P of 0 over P of 0. So the percent that it increased or decreased if you're unlucky. Okay, so let's see how we would compute this. Okay, so in fact, I'm actually going to do this backwards. I'm going to do this one first because you actually kind of need this computation in order to do this computation. And so that's going to show us why using this is much simpler. Okay, so suppose we wanted to know this. How do we do that? Well, consider this. P of t over P of 0. This is equal to P of t over P of t minus 1 times P of t minus 1 over P of t minus 2, and so on and so forth, up to, let's say, P2 over P1 times P1 over P0. Okay? And what do we notice? We notice that these are the daily return, or the daily gross returns, which you know how to compute in code. Okay, so this would be equal to 1 plus RT, so the gross return, 1 plus RT minus 1, okay, down to 1 plus R2 times 1 plus R1. Okay, and so this is equal to the product, T going from 1 up to T, 1 plus RT. Okay, so what is this? This is the cumulative product. Okay, so why is it the cumulative product? Well, that's because for any time big T, we're just doing the product from time 1 up to that time. Okay, and so now let's say we wanted to know the simple return. What would that be? Well, the simple return, this is the same as PT over P0 minus 1. And we already found this up above. So that's the product from T equals 1 up to big T, 1 plus RT minus 1. Okay, so you can see how if you wanted to compute the simple return, it's just another step. So might as well just compute the gross return. Okay. Now, you'll notice that we have a product here, okay? And so how does this relate back to what we saw in the previous lectures? Well, you recall that in the code, ChatGPT suggested using the function cumSum. Okay, and so what this does is it computes the cumulative sum, not the cumulative product. So this is just an aside, what this does. So what this would have done, what ChatGPT thought you should do, is you should compute the sum of the returns. Okay, so that's what it was doing. So it was saying sum of RT, T equals 1 up to T. And as we've seen, this is not correct. This is not anything. Okay, instead what we want to do is we want to compute the cumulative product of the gross return, not the cumulative sum of the simple return. Okay, now it turns out that this is, well, I've said it's wrong. It's not completely wrong. It actually gives you an approximately right answer, but it's not mathematically correct. Okay, and so I'll explain why that is right now. Okay, so there's another quantity called the log return. Okay, so the log return, what letter am I going to use for this? I should have used capital R up there so that I could use lowercase r down here, but it's too late for that now. So I'm going to use another letter. So please forgive me for this. I'm going to use the letter rho. Okay, so this is our log return just for this lecture, rho of t. And this is equal to, it turns out, the log of the gross return. Okay? And so another way to write this, what is 1 plus r of t? 1 plus r of t, as we've seen, is the price at time t divided by the price at time t minus 1. And using the rules of mathematics, we know that we can separate this. So we get log of p of t minus log of p of t minus 1. Now, you might recognize this as the log price if you've taken my courses on time series or finance before, but that's not really needed for this course. Okay, so all you really need to know is this, or this equation for how we compute the log return. Okay, so now the question is, well, we have the log return. Why is this more convenient? Why can we sum it, as I suggested in the previous lectures? So actually, we are going to use the concept of the log price. Okay, so let's say we wanted to know the log return from time 0 up to t. Okay, if we wanted to do that, we would have log of p of big T over p0. Okay, so what's this? So this is the log return of the strategy for the duration that we ran it. Okay, but we know this. So what is this? From above, it's this cumulative product. Okay, so we have log of the product time t equals 1 up to t of 1 plus rt. Okay. But what is this? So we know from our high school math studies that the log of a product is equal to the sum of logs. Okay, so how we can use that here is we can switch these two and the product turns into a sum. Okay, so we get the sum, t equals 1 up to t, and then we have log of 1 plus r of t. Okay, but what is this? This from above, that's the log return. T equals 1 up to t rho of t. Okay, so this explains why ChatGPT made this mistake. Okay, so it confused the fact that you could sum up log returns in order to get the total log return of the strategy, and it mixed that up with regular percent returns or simple returns. Okay, but you can see how this is much more convenient because this is sum, and in code it turns out that summing things is much more computationally efficient than multiplying things. So that explains why we'd prefer to do a sum when you see it in code. However, at the same time, using log of things is not really intuitive. So I find that people don't really understand, why do we have a log price? What is the meaning of log price? When I spend my money, the person at the store doesn't tell me the amount of log dollars that something costs. They tell me the amount of dollars. So intuitively, we don't see log things in our day-to-day lives. So I can understand if it's not intuitive in that sense. But mathematically, it's much more convenient. Okay, and so the final thing I wanted to mention in this lecture is the baseline value when you are computing cumulative simple returns or cumulative log returns. Okay, so just really quickly, So when you're looking at log returns, the baseline value is 0. And when you're looking at gross returns, the baseline value is 1. Okay, so why is this? So basically, the baseline value is the value that you have when you didn't make any money, but you also didn't lose any money. Okay, so I think it's easy to explain with respect to the gross return. Okay, so the gross return, if your return is 1, if your gross return is 1, that means your money was multiplied by 1, which means it stayed the same. Okay, whereas when we have the log return, we sum, so we start from 0. So when your log return is 0, that means you didn't make any money. And so why is that? Well, suppose that you had the log P of t over P of 0, which is the log return of your strategy. But we're saying you didn't make any money. So your initial price is P0 and your final price is also P0. But this is log of 1 and that's 0. Okay? Okay, so the baseline value for log returns is 0. And so why is this important? Well, this is going to show up in the code. So just as a little preview, what's going to happen is because when we're computing rolling windows, so we have some time series like this, and the rolling window to compute the mean is, some number of days, like 30 days. But the problem with that is that when you do this, so suppose we computed, the rolling mean of the above signal, and it's that. But now you'd be missing the first few values because you don't have enough data to compute the actual mean. So you need 30 data points to compute this value. Okay, and so what happens with that is it means your strategy, your positions, basically every variable you compute from then on will have not a number for these first few values. Okay? And so the problem is when you compute the performance of your algorithm, you want to have some value for your performance within this period. And so basically what we assume is that in this period, because we don't know this rolling mean, which means we won't know the Bollinger Bands, we won't know anything. We're just not going to do anything in that period of time. So in that period of time, basically, we'll make no money. But we'll also lose no money. In other words, our strategy in that time period is constant, which means we need to fill it with one of these values. Okay? And so what value we fill it with depends on whether we're computing gross returns or log returns. Okay, so that's the whole point of this discussion, is what are we going to fill these values with later in the code. Okay, so in this lecture, we're going to discuss more about returns and log returns. So I realized after I made the previous lecture that I forgot to discuss one thing. So I mentioned in the lecture that the thing that ChatGPT was doing, so it was doing this. It was summing all the returns to get the return at time big T. And I said that this is approximately correct. So why is this approximately correct? Okay, and so the reason is, so you recall that I said that this is correct, so we can do this with the log returns. This is okay. Okay, so why is this okay and this not okay? So we've already shown why this is okay. I've shown you why that works and how it's related to the cumulative simple return. So why is this one almost okay? And so the reason is that the log return is approximately equal to the return. And it turns out that I just released a calculus course about a month ago. And so now we have the tools to explain this. So if you took that course, you will understand this. If not, that's okay. Don't worry about it. Okay, so just for interest, why are these almost equal? So let's write down what this is. So this is actually, so I'm saying R of t is approximately equal to log of 1 plus R of t, right? Because that's what the log return is. And so the reason this is, well, the easiest way to see this is if we do the first order Taylor expansion. Okay, so what is the first order Taylor expansion? So we're going to center the Taylor expansion around x naught, or I guess you could say r naught. Yeah, x naught's fine. Okay, so actually it's easier to write this way. So let's say f of x is equal to log of 1 plus x, and we want to show that f of x is approximately equal to x. Okay, and we're going to center x around 0. And so we learned that the Taylor expansion, the first order Taylor expansion, looks like this. So we have f of x naught at 0, this is approximate, plus the derivative f prime x evaluated at x naught times x minus x naught. Okay? And so what is f of x naught? So that's log of 1 plus 0, okay, because we set x naught equal to 0. And then the derivative is 1 over 1 plus x, evaluated at x naught equals 0, so we'll say 0. And then times x minus x naught, which is 0. Okay, so what does this give us? Well, log 1, that's 0. 1 over 1 plus 0, that's 1. Times x is x, so this is equal to x. Okay, so we've shown that when x is very small, in other words, close to 0, f of x is approximately equal to x. Okay, so that's why we can say r of t is approximately equal to log of 1 plus r of t, which is why the cumulative simple return is approximately equal to the cumulative log return. Okay, so hopefully that explains that. And now I also want to take this opportunity to explain the log return calculation we saw in the code. So it looks like this. So we take the log of asset divided by asset dot shift 1. Okay, so let's explain why this works. And it's also useful because this shifting is also used when we compute the portfolio returns, which happens in the next step. So as you recall, for that computation, we end up shifting the portfolio asset position. Okay, so let's see how this works. So recall that you can think of the asset prices as a table. So we'll say, here's the price, and here's price shift 1. Okay, so let's say this is P1, P2, P3, P4, P5, let's just say. And so what happens when we shift 1? Well, that means we shift everything up by 1. So this would become NAN because nothing comes from before, and then P1 goes over here, P2 goes over here, P3 and P4. Okay, so everything is shifted up by 1. Now, what happens when you take this divided by this, and then you take the log? Because that's what this does. So we're taking the log of this whole array divided by this whole array, right? And it's doing an element-wise computation. So the log return, this is this divided by this, which is just NaN because there's an NaN in there. And then we have this divided by this, and then we take the log, so log of P2 over P1. This divided by this, which is log of P3 over P2. Log of P4 over P3. And log of P5 over P4. Okay? And this is the log return at time 2, the log return at time 3, log return at time 4, log return at time 5. Okay, so hopefully now this computation makes sense. Okay, so in this lecture, we're going to talk about how we compute the portfolio return. Okay, so by that I mean not the whole return of the whole strategy, I mean the daily return, given what we've shorted or longed for each stock. Okay, so we saw in the code that it looks like this. So the portfolio return is equal to asset 1 position is shifted by 1 times, let's call it the return for asset 1. So we'll say, let's say R1 at time t. And we'll say this is the portfolio return at time t. And then plus asset 2 position shifted up by 1 times the return at time t for asset 2. Okay, so there are two issues with this that I want to talk about. So first is, why do we shift and why do we multiply? So why is that allowed? And then after that, we're going to talk about another issue, which I just discovered right before I made this lecture, like not even 1 minute before, that I didn't realize, the last week as I've been going through this. So we're going to discuss that as well. But first, let's just talk about the timing and make sure that that makes sense. Okay, so we're again going to draw a table. So here's the price. And now let's just start at P0. It makes things a little simpler to look at. Okay, to P3, P4. Okay, now let's suppose we've also computed the log return. Okay, so as you know, this would be NAN. This would be log return at time 1, log return at time 2, log return at time 3, log return at time 4. And now let's suppose we have, some fictitious position that our algorithm discovered. Okay, so it says here we do nothing, here we do nothing, here we go long, here we go long, here we go long. Okay, and as per above, we want to know what happens when we shift this up by 1. Okay, so now this is NAN. This is 0, this is 0, this is 1, this is 1. Okay, and so we're saying that the portfolio return, or let's just call it the strategy return, because we don't have a portfolio here. We're just looking at one asset. We're trying to figure out why we're shifting. Okay, so the strategy return for here would be NAN, because it's just this multiplied by this. So NAN. And then the next one would be 0 times this, which is 0. The next one would be this times this, which is 0. And this times this, which is row 3, and then we're row 4. Okay, so the total log strategy return would be row 3 plus row 4. Okay, so now we're trying to figure out why this makes sense. So, as mentioned, really this is an approximation. Okay, so what are we doing? First of all, the table itself is an approximation, right? Because as mentioned, you can trade at any point during the day, at which time the price fluctuates. So what we are doing is we're approximating the price as being a discrete signal. Okay, so here's time 0. Here's some fictitious price. Here's time 1, here's time 2, time 3, time 4. Okay, so here's the price, here's the price, here's the price, and here's the price. Okay, so this is P0, P1, P2, P3, P4. Okay, and really we've used the close price for this. So this price is really the price at the end of the day. Okay, but we're assuming it's the same price all day. Okay. So now what does this position tell us? It tells us that on day 2, we go long. So on day 2, we go long. So if you're wondering, why doesn't the return for day 2 add to our strategy return? So why don't we get row 2? The reason is that we go long on day 2. Okay, and if we went long on day 2, think about what the return on day 2 is. So the return on day 2, row 2, this is equal to log plus, 1 plus R of t. What's R of t? Well, 1 plus R of t is P2 over P1. Okay, but if you went long on day 2, you don't get the return from having the stock at price P1 going to P2. Okay, you're actually buying at P2. So you only have stock purchased at price P2, which means the first return you get is row 3, going from P2 to P3. Okay, so hopefully that makes sense. So you went long on day 2. At any point during this day, it doesn't matter because that's after P1. So you don't get to buy at price P1, which means you don't get the return, which depends on P2 and P1. Okay? So hopefully that explains why we've shifted the position in order to determine the strategy return. Okay, so now here's issue number 2 that I didn't realize until today. So we have the portfolio return. Let's just make it simple. So we'll say position 1 times the returns for asset 1 plus the position 2 times the returns for asset 2. Okay. So why doesn't this make sense? This doesn't make sense because if you think about it, position 1 is always the negative of position 2 in our strategy, right? Because position 1, I believe it's long minus short. It could be backwards. I know we had problems with that earlier. It doesn't matter because the principle is still the same. Okay, so position 2 is actually the negative of long minus short, which is the negative of position 1. So we're always taking the negative position. Now, does this make sense? It might seem to make sense at first, because why not? But if you think about it, it doesn't make sense. Because you see what's happening here. So think about it this way. You have a certain amount of money. You have $100. Okay? And let's say our strategy says, go long on asset 1. Okay, so you're long on asset 1. So does that mean you purchase $100 worth of stock in asset 1? Or does it mean you short asset 2 with $100? Right? You only have $100 to invest. In other words, you can't do both at the same time because that would require double the money that you actually have. Okay, so now let me try to explain why this is a more complicated problem than it seems at first glance. It's really an open-ended problem, okay? And the reason why that is, so one thing to consider is that short selling is really borrowing. So for the purpose of this course, let's just keep things simple. There's no limit to what you can borrow from your bank. So you can borrow $100, you can borrow $200, you can borrow $300 to initiate your short position. Okay, so it doesn't have to necessarily equal the $100 you're starting with. So that's one way of looking at it. So another way of looking at it is from the portfolio perspective. So we talked about in my financial engineering course, the concept of the portfolio, where you have portfolio weights. So let's say you have D assets, and you have the weights W1, W2, up to WD. And the constraint is that these weights must sum to 1. Okay, so that's one way of looking at this. I don't like this way for this example, though, because what happens is, let's say we took our $100 and we went long in asset 1. What that means is if we want our weights to sum up to 1, we'd have to set asset 2's position to 0, right? Because if W1 is 1 and we want the whole thing to sum to 1, we must set W2 to 0. Okay? But what if, let's say, we invest 50% of our $100 in asset 1, then what does W2 become? This also must be 50%. But in the context of this example, this whole thing is W2, which means you'd have to go long in both, which doesn't make sense because we want to go long in one and short in the other. So just to be clear, what we mean by short selling, that means we would set W2 to be, say, minus 0.5. So that's shorting. Okay? So here's another way of looking at this, though, which I've seen, is instead of having the constraint that all the WIs must sum to 1, we can set the constraint that the absolute value of the WIs must sum to 1. And in this case, this allows us to put half of our money into asset 1, and then the other half shorting asset 2, right? Because if we have 0.5 plus the absolute value of minus 0.5, that's still equal to 1. Okay, and really this depends on the mechanics of short selling. And in this course, we're really interested in the math and not so much the mechanics of how you deal with your bank, because that's going to be, really an individual situation for all of us. So for the purpose of this course, what we will probably end up doing is setting these both to 0.5 and minus 0.5. I think that makes more sense. Because otherwise, think about what you're doing if you do what ChatGPT suggested, which is to take a weight of 1 for both. So what does that mean? That means basically, let's say you long asset 1 with 100% of your money, and then you just happen to borrow the same amount to short sell asset 2. Okay, so what that would do essentially is that would double your volatility. Okay. Now, do you want to do that in the real world? I can't answer that for you. But what I think we're going to do, just to keep things simple and noting that it still does make sense and it's still possible, we might just keep the code the same just so that we don't have to change this part. Okay, so let's just say, you know what, we're not going to do this. Let's just say we're going to do this and put 100%. So if we long asset 1, which means we also short asset 2, then we'll say put 100% of the money into asset 1 and short asset 2 the same amount. Okay, so just note that this is more like a user-defined constraint rather than a mathematical constraint. Okay, so there's no reason mathematically we have to do this, but the user may define this themselves, by saying, okay, I don't want to ever short any more than the money I already have. Okay, so at this point I was kind of tired of finding all these errors, and I decided I just wanted to put this into code. And as you recall, there's one order of business we still need to take care of, which is asking ChatGPT to load up these assets correctly. Right, so currently it's looking for asset1.csv and asset2.csv, which don't exist. So we need to ask ChatGPT to fix that part. So I said, please help me find 2 good assets for this pairs trading strategy. And so ChatGPT says, when selecting for a pairs trading strategy, it's important to look for assets that are highly correlated with each other. You can start by looking at assets that are in the same industry or sector, or that have similar business models. Here are two possible assets that you could use for a pairs trading strategy. So number one is Coca-Cola and Pepsi. So Coca-Cola and PepsiCo are both large multinational beverage companies that produce similar products and operate in the same industry. They have a strong positive correlation, making them a good choice for a pairs trading strategy. Number two, Microsoft and Apple. Microsoft and Apple are both large technology companies that are leaders in their respective industries. They have a positive correlation, making them another good choice for a pairs trading strategy. Of course, before implementing any trading strategy, it's important to do your own research and analysis to make sure that the assets you choose fit your investment goals and risk tolerance. Okay, so there's two ways we can go about this, right? We can just do what ChatGPT suggests, and another way is to actually look into what it's saying. So it's saying that we should be looking for two assets that are highly correlated with each other. Okay, and so you may or may not know what this means. If you've taken my financial engineering course, then you do. But if you haven't studied this before, then maybe you don't. So basically, there's a statistic called the correlation that you can compute between two data sets. And these two data sets would be the returns for the two assets. So if you wanted to check the correlation between, say, Coca-Cola and Pepsi, you would compute the statistical correlation between the returns of these two assets for some window, for example, the past year or the past 60 days. Okay, and as always, the number of days you choose is a hyperparameter. Okay, so that's up to your own experimentation. We can't tell you exactly how many days you would use. Okay, so now given that, another thing you could do is instead of asking ChatGPT to select your pairs, you could just go through, say, the top 1,000 stocks in the US market, let's say, and compute the pairwise correlation between all of those assets. And then based on that, choose the ones that have the highest correlation, or the highest negative correlation as well, since that would yield a similar strategy. Okay, but in any case, we're ready to code. So let's, right. We're not ready to code because it hasn't given us the code yet. Okay, so the next step is please write the code to get asset prices for KO and PEP. To get the asset prices for Coca-Cola, KO, and PepsiCo PEP, you can use the Y-Finance library in Python. Okay, so that's a good thing because we've used this library before. So it says, here's an example code that retrieves the historical prices for KO and PEP from January 1, 2020 to March 18, 2023. You know what? This is actually interesting because I heard that ChatGPT doesn't know the date because it was only trained up to somewhere in 2021. So I guess this is an upgrade where it now knows the true date because this is around when I started making this course and doing these prompts. So that's interesting. So anyway, this code looks correct. So let's read what it says. So the code downloads the adjusted close prices for the two tickers from Yahoo Finance using yf.download function. The function takes a list of tickers as input as well as the start and end dates for the historical data. In this case, we're retrieving the data from January 1, 2020 to March 18, 2023. The function returns a data frame that contains the historical prices for each ticker. We then select only the adjusted close column of the data frame using indexing. Finally, the code prints the last 5 rows of the prices data frame using the tail method to verify that the data has been downloaded successfully. Okay. So let's copy this code. You know what? It won't copy because this is just a saved document from before. Okay, so here is Colab Notebook, and I'm going to paste that code. I'll start a new line here so you can see everything. Okay, so this downloads the two assets successfully. And now we're going to go back up and we're going to take the latest version. So usually, as mentioned, you can click the copy code button, but because this is a HTML document that I saved, you can't do that. Okay, so I'm going to take this code and I'm going to paste it in here. But remember that there are things we have to change. So these imports, I'm going to take those out. I'll probably put those up at the top. Just put that up there. And so now this goes away because the assets are coming from above. So here's something we're going to have to do ourselves. I'd rather not have ChatGPT do this. We'll say asset 1 is equal to prices KO, and asset 2 is prices PEP. Okay, so I think that should work. You know what? Let me do this. So we'll keep them as data frames. I didn't do this the first time, but it might help. We'll see. Okay, and it's just a comment there. Okay, so you recall in the last version there was still a mistake because in the earlier versions of this code, ChatGPT was using upper and lower bound, but it somehow changed to -1 and +1 later on. So we're going to change this back to lower bound and upper bound. Okay. Oh, and this thing, the asset positions were backwards. So we'll say long minus short and minus long plus short. And I think this should be fine. And originally this didn't work because we didn't have pandas data frames, but it might work now, even though it does not do anything. So let's just run this. Okay, so it appears to not work. So we'll have to figure out why that is. Okay, so now I want to point out, that there are many paths you could take through this journey, right? So at this point, something you could have tried that I didn't try is you could say to ChatGPT, this just prints out a straight line, please fix it or something. I didn't do that because I just ended up using my own knowledge of Python and finance to fix this. Okay, so keep that in mind, is that what you see in this course is only because that's what I decided at the time. But what you decide is going to depend on you. Okay, so I guess this is going to turn into a little lesson on debugging. So here's what I would like to try. So let's just start with spread. And let's just plot this to make sure it looks nice. Okay, so spread is nothing. So maybe I made a mistake. And it's probably because of this. You know what? That's so weird. Okay, we'll try asset 1 and asset 2. Asset 1. Yeah, that's fine. Asset 2. Okay, that's fine. But when you subtract them, it's not fine. Okay, so maybe we do have to have them as a series. In which case, we'll change this. Okay. And so notice how now that they're series, this line doesn't work, which is what I encountered the first time. But at this point, we should be able to plot the spread. Okay, and the reason this didn't work the first time is because this was the way I did it originally, and I changed it on the fly. Okay, so now this works at least. Okay, and so basically, we don't even need this line. It does nothing. Okay, which is what I mentioned earlier in the theory lectures. So we just take this and we do the cum sum. Okay, so let's run this again. Okay, so now it works. So our total return is log return. It's about 15% over this 3-year, 2-year, 3-year period. Okay. And one thing that's interesting about this is that early period of the pandemic where there was a big drop in the market, it appears that this strategy didn't suffer from that. So that's kind of interesting. So maybe if you want to avoid large and sudden crashes, maybe pairs trading is something to consider. Okay, so here's another thing I didn't do the first time I ran this. I never tried the other 2 assets that it suggested, which was Microsoft and Apple. So we can try Microsoft and Apple as well. So we'll say tickers equals Microsoft and APL. Okay, and just to make this so we don't have to keep changing it, we'll say just tickers 0 and tickers 1. And does it appear anywhere else? No. Okay. Okay, so if you use Microsoft and Apple, you would lose money. So about 20% loss. Okay. Okay, so I think that's enough for this lecture. That's basically all I wanted to do, was get our assets and make sure that the code works as a first step. But we will be doing a few more changes in the coming lectures, so look out for those. Okay, so in this lecture, we're going to continue looking at the code we just wrote. Now, certain aspects of it made me think that it was doing something weird, and so I thought it would be a good idea to double check what's happening. So what I'm going to do is I'm going to rerun everything. So you see I've set our tickers back to KO and Pepsi. So we're going to rerun everything up to here. Okay, so that ran. And now we're going to plot the trading signal. Okay, so basically asset 1 position and asset 2 position. Okay, so plt.plot, asset 1 position, plt.plot, asset 2 position. Okay. Okay, so now this looks weird. So it's basically saying go long on this and go short on this for the whole period, which kind of doesn't make sense, right? Intuitively, we know that if our z-score is really mean reverting, it should go above the mean sometimes and below the mean sometimes, which means we should probably have a mixture of longing and shorting. So this seems very weird, and in fact is wrong. So what we're going to do is we're going to look at the spread versus the upper and lower bound, and we'll find a bug that we didn't see before. Okay, because what's supposed to happen is we're supposed to have, when the spread is lower than the lower bound, we go long, and when the spread is above the upper bound, we go short. Okay, and so we're going to check what is this spread z-score, what is the lower bound, and what is the upper bound, and we're going to plot these as a time series. Okay, so we're going to do plt.plot. We could label them, but I don't really care right now. No, you know what? Let's label it. So label spread, lower bound, label, let's call it LB, and upper bound, label equals UB, and then we'll plot the legend. Okay, so now it's clear we have a problem. So this is the spread. This is the upper and lower bound, right? They're not even close. So what seems to have happened is the lower and upper bound are not based on the normalized value, whereas only the spread is normalized. So what we're getting is the spread is always above the upper bound, which explains why we just have the same signal throughout. Okay, so in fact, the bug is we don't even really need to compute the spread z-score, right? Really, the only thing we needed to normalize were the assets. But when we have the spread, we don't need to normalize the spread, right? So we can get rid of this, and it's really the spread mean. And the spread mean lower than the lower bound or above the upper bound. Okay, so let's run this again. Okay, now we have another problem. So our algorithm just returns 0 all the time. So let's plot this again. So why is it always 0? And we'll say spread mean. Okay, and so in this case, okay, I see what's happening. Okay, so that's my mistake. It should not be spread mean, it should just be spread. Right. Okay, so we have spread. Okay, so now it makes sense. So now we're making like 25% return, which is even better than before. Okay. Let's see how our position goes. Okay, so you can see here now, the position often switches from long and short. Okay. And again, notice how they're opposite. So when one is long, the other is short. Right. And this is also just the spread. Okay, so it's a bit hard to see because it's a little small, but you can see where the spread goes above the upper bound and below the lower bound. Okay, so one question always worth asking when you implement a trading algorithm is, does the algorithm beat buy and hold? Okay, because if buy and hold performs well, then there's really no point in putting effort into trading. Okay, so in order to test that, what we're going to do is we're going to plot the asset prices. So we have asset 1. Okay, but remember that we now have log returns, and we're computing the cumulative log return to check the performance of the algorithm. So we want to do the same thing with the assets. Okay, so it would be np.log asset1, or you know what? I believe we already calculated this. Right, asset1 log returns. Yeah, so we just do that and then come sum. Label that asset1. Okay, we'll do the same thing here with asset2. And then we'll plot the algorithm itself. Okay, and we'll draw the legend as well. Okay, so interestingly, what we see here is that the algorithm actually does not beat buy and hold for the second asset. It does for the first asset though, so it's kind of in between. But one thing we can see is that the variance or the risk is much less. So, for example, there's a huge drawdown here. That's from COVID. And then, there's lots of variance in the signal. So it goes down a lot, goes up a lot. Whereas the strategy is pretty constant. So, one thing we can try, it could be a fluke that this is performing well. So suppose we started, say, after COVID, that big drop in March. So we'll say, I don't know, June. Let's run this again. Okay. And so now you see this algorithm greatly underperforms buy and hold. So if you just did buy and hold, you would have done very well. So this just goes to show it's not always a good idea to run an algorithm. Oh, and another thing we can try is, so we can go back to January 1 and we'll use Microsoft and Apple. Okay, so let's run this. And so really, there are so many combinations you could try, right? You can try different dates. You could try before the pandemic because, after the pandemic was a pretty anomalous trading regime, right? So you had that big drop and then you had a big run up when everyone had lots of money to invest. And then the market crashed again in, June 2022. So, or you might want to try a period before that, just because the past few years have been so crazy. Okay, so anyway, let's see how Microsoft and Apple do. Okay, so we get about 35%. That's pretty good. And there's no large drawdown, which is also good. I wonder. So again, it underperforms buy and hold. But I wonder the reason that maybe it misses this large drawdown, is it because perhaps we just didn't have enough data at that point and it just does nothing? Or is it because we really made money from that drop? So let's go even before 2020. Let's go to like 2018 and maybe let's go up to 2021. Okay. Okay, so now you can see, well, it's not that bad. Okay, so where is the pandemic here? Pandemic is right here. Okay, so now the strategy, it's very small, but it does drop a bit during the pandemic period. Okay, and it greatly underperforms buy and hold. So notice how buy and hold, we get a log return of 1. So I guess as an exercise, you can compute what the actual percent return is. But you can see that the strategy is nowhere close. Okay. Okay, so there's one problem with what we just ran, if you noticed. So you recall that we started this conversation with the idea that the spread was supposed to be mean reverting, right? And so it was supposed to be centered around some mean, sometimes going above, sometimes going below. And we use the lower and upper bound to check how far above and how far below before we initiate a new trading signal. But you can see here what's going on is that this spread signal is not even stationary. It's just going down. And if you think about it, what we're doing up here is we're computing the spread from the original asset prices. Now, I'm not sure if I made a comment on this earlier, but I will now, that this is not really right. So imagine, let's say, so we have two assets. Now, let's say asset 1 is on the scale of, say, $0 to $10, somewhere around there. But asset 2 is somewhere on the scale of, say, $900 to $1,000. So what happens if you subtract the two is you're just going to be on the scale of the bigger asset, because the asset on the smaller scale isn't going to have much of an effect on the subtraction. So what we really want to do is not this. We want to have normalized or standardized the asset prices first and then computed the spread. Okay, so it should be Z1 minus Z2. And so this is one of those things that ChatGPT changed on us. So you'll see further down, it's doing spread equals asset 1 minus asset 2. But originally, it was doing Z1 minus Z2. Okay, so let's run this again from here and see what happens. You know what I should have done? I should have kept both so we could see the difference. So let's keep the old one too. Let's run that again. Although do keep in mind that this is only a signal that you're correct or not correct, right? Because sometimes, I mean, you can do things that completely don't make sense and it will still appear to work. So this is only a signal that you're doing things right or wrong. Okay, so what's the return for this? About 25%. Okay, and then here we get that funny spread, which is not mean reverting. And it does not beat buy and hold for one of the assets. Although it does do a nice thing up here. Okay, so now we're going to get rid of this incorrect version of the spread. I'm going to use the correct version of the spread. Okay, and so now our return is much lower, it appears. Or maybe I was counting the scale wrong before. That's also possible. But at least now our spread is actually mean reverting. And so you see how it occasionally goes above the green line or below the orange line, but generally it stays around 0, which is what we expect because these are from normalized signals. Okay, and this does not beat our buy and hold. However, do keep in mind that just like all the other lectures we've seen so far, we are not yet done fixing things. Okay, so there is another thing we are going to fix in the next lecture that will hopefully make this better. Okay, so in this lecture, we're going to talk about the concept of extending the trading signal. Okay, and so why are we talking about this? Well, if you noticed in the previous lecture, what we got for our cumulative return, it looks something like this. Like it didn't move very much, and it was just these sort of horizontal lines. Okay, and so why was it doing that? Why was it horizontal most of the time? And the reason that is because most of the time we were in between the Bollinger Bands, and when we are in between the Bollinger Bands, the trading signal is 0. The asset position is 0, and for both the long and the short signal. Okay, so let me draw that out. So, here we have this. So these are our two Bollinger Bands. Here's the spread. So we might go above and below sometimes, but most of the time we're in between. And so recall that we set long is equal to spread less than lower bound, right? And short is equal to spread greater than upper bound. Well, when does this happen? This only happens for very short time periods. Because, by definition, 2 standard deviations away from the mean shouldn't be happening that often, right? I guess depending on the distribution. Okay, so this actually doesn't make sense. Okay, so why does this not make sense? So if you think about it, so let's just think about, we have a mean reverting signal. Well, we can just look at this one, I guess. So we have a mean reverting signal. Why would we only want to be short over here? Right? We actually want to be short for this whole period so we can ride the decrease in the price all the way down to the bottom and make money during that decrease. And we want to not only long at the bottom, we want to long for this whole period so that we get the profit when it goes back up. Okay, so hopefully I'm making sense. And you can see why we want to extend the short signal and we want to extend the long signal. Okay, and so that's what we'll be doing in the next lecture in the code. And I guess I'll explain the code here as well, just so you can hear it twice. Okay, so what we have right now, we have something like this where, so first we have some NANs because there's no trading signal there. And then we have, long goes up sometimes. So imagine this is long, right? So recall that long and short, they can only be, well, the asset position can only be 1, 0, or -1. Okay, so, I might do something like that. Okay, so these are all zeros. And what I'm saying is we want to fill these values with the same value. Okay, so if this is 1, that means we want 1, 1, 1, 1, 1. And if this is -1, then we want -1 all the way. So -1, -1, -1. Okay, so you get the idea. Now, the issue with this is that there is a function in pandas, it's called ffill, the ffill function. And what this does is it fills not a numbers with whatever the previous number was. Okay, so if you have a signal like this, and then there's just something missing, then what it'll do is it'll just copy the same value forwards. Now the problem is ffill only fills NANs. It doesn't fill zeros. So what we're going to do in the code is we're going to replace all these zeros with NANs first. So we're going to make these into NANs. Make these into NANs. And then we're going to replace those NANs with the forward fill. Okay, so that's what we're going to be doing in the next lecture. Okay, so in this lecture, we're going to work on this problem of extending the signal because our cumulative return seems very flat. And the reason that is because most of the time it's doing nothing. Okay, and you may have noticed that this comment was here the whole time, that we might want to extend the trading signal. Okay, so let's go back up here. And so what do we need to change? We basically need to change asset 1 position and asset 2 position. Okay, so what we're going to do, I'm going to say extend the signal. And I'm going to first make a copy, just in case we want to make use of what we had before. So I'm going to copy this, and as mentioned in the theory lectures, because we can't forward fill on zeros, we have to forward fill on NANs. I'm going to replace all the zeros with NANs. Okay, so wherever this is 0, I'm going to set it to np.nan. And then I'm going to now ffill. I think it's just ffill. I'll say in place equals true. And then we'll do the same thing for asset 2. asset 2, asset 2, asset 2, asset 2, asset 2. Okay, so let's run this. Okay, so now you can see our return has gone up to about 40%, whereas before it was like something like 0.04%. Okay, and so here's the asset positions. As you can see, they extend forward, so it's now always either +1 or -1. It's never 0 unless it's at the beginning. And then, so here's the spread again. Okay, and so now you can see most of the time our algorithm, which is in green, it now outperforms buy and hold most of the time. Okay, so in this lecture, I want to continue looking at the prompts that I used with ChatGPT, just to show you what happens and how you can deal with it. So you'll recall that there was a bug in the code, which we just removed manually, but I did try to get ChatGPT to fix it at some point. So you recall that this line does nothing because we have a panda series, so there's no point in summing this across axis 1, which doesn't exist. Okay, so what we really ended up doing was copying this value, this variable, portfolio log returns, into here, and then computing the cumulative sum. Okay, so there's no such thing as total log returns in our code. Okay, and so let's look at how I got ChatGPT to fix that, or tried to get ChatGPT to fix that. Okay, so where are we? So I said, I'm getting this error when running the previous pairs trading code. And so I referred to the previous pairs trading code because the last thing, so I didn't want ChatGPT to think it was referring to this, which was just the code to load data from Yahoo Finance. Okay, so I pasted this error, value error, no access name 1 for object type series. Okay, and so let's look at what it says. So the error, value error, no access named 1 for object type series occurs when you're trying to perform an operation that requires a data frame, but you're passing a series instead. In the context of the pairs trading code, this error can occur if the spread variable is a series instead of a data frame. To fix this error, you can convert the spread variable to a data frame. Okay, not really what we were going for, but that's okay. Before trying to compute the z-score. Here's an updated version of the code that converts the spread variable to a data frame using the toFrame method. Okay, so this is definitely not only the wrong solution, but it's wrong in so many ways that I think it's worth talking about. Okay, so firstly, why this is logically wrong is because even if you do convert everything into a data frame, everything still has one column, which means there's still no point in summing the columns, right? You're just summing one thing, which is that thing. Okay, so it really doesn't make any sense to do it this way. You're like just changing everything else to, make this error okay, which is not really what you want to do. You really, as we saw, you just want to remove that line. Okay, and the second reason why this is wrong, I just alluded to that previously, but you really don't want to, in the name of fixing one error, to change everything else that came before. Okay, so the problem here is now everything basically up to the beginning of the script has changed, and it's not clear if this even works. So there are several things it did that introduced errors. Okay, so I'll go through some obvious ones. I'm not going to go through everything because that would require us to run this code, which doesn't even work, which is pointless. But let's try to find some. Okay, so here's one. So we have a variable now called window size, which hasn't been defined anywhere. Okay, so ChatGPT just made that up. And then we have another variable called entry threshold, again, which doesn't exist. Recall before that these were the upper and lower bound. And then somehow ChatGPT changed this to -1 and +1. And now it's changed again into some random variable that we haven't even defined. Okay. And now it's computing the returns in a totally different way. So instead of computing asset positions, it's just taking long and short signal directly. And, maybe this is right. You'd have to write it down. I'm not sure. So let's see. So we get long times KO percentage minus short times KO percentage. Okay, so that makes sense. So if you did this in math, just write it down on paper. I just did it in my head, but I think it's right. So if you simplify this algebraically, you'd get the KO return times long minus short, and long minus short is the asset one position. And then because these are negative over here, you'd get PEP percent return times short minus long, which is asset two position. So it seems to work, but this is a really dumb way of computing it because you're computing the percent change twice. Okay, and notice how it's gone back to the simple return, the percent change. And so because of that, now somehow it knows how to compute the return. It's not summing by mistake anymore. So now the cumulative return, as we learned, is the cumulative product, but you add 1 to the simple return first, and then you subtract 1 at the end. Okay, so some of this would work. A lot of it wouldn't. So the real problem is, if you try to, at this point, let's say, continue the conversation with ChatGPT, it might continue to use this, which is really annoying because all our code is based on what we had above, right? So, and it's not clear if you can make ChatGPT go back to what it had before. I didn't try that, but it's maybe something you could try. Maybe start a new chat window and then paste in the old code and then see if it can continue on from there. But I haven't tried that yet at this point. Okay, so in this lecture, what I wanted to do was to ask ChatGPT to suggest more pairs to trade. Okay, so I said, please suggest more pairs to trade, and it says, sure, here are a few more pairs of assets that you could consider trading using a pairs trading strategy. Okay, so it says Visa and MasterCard. Visa and MasterCard are both leading companies in the electronic payments industry. They have a high correlation, and their stock prices tend to move in tandem, making them a good pair for a pairs trading strategy. Number 2, Procter & Gamble, PG, and Johnson & Johnson. Okay, Procter & Gamble and Johnson & Johnson are both large consumer goods companies that produce household and personal care products. They have a positive correlation, making them a good pair for a pairs trading strategy. Okay, number 3, AT&T and Verizon. Okay, so AT&T and Verizon are both leading telecommunications companies that offer similar services. They have a positive correlation, making them a good pair. Okay, it says the same thing again and again. Okay, remember, it's important to do your own research and analysis to ensure that the pairs you choose fit your investment goals and risk tolerance. Yeah, okay. So, interestingly, it's kind of interesting that ChatGPT makes these choices based on industry and sort of, I guess this is what I would call soft knowledge. Knowledge basically that's non-mathematical, right? So one strategy you could have used, as mentioned earlier in the course, is to compute the actual numerical correlations between the returns of different assets, in whatever universe of assets you want to consider. But this is more of a qualitative choice. Okay, so in any case, we're going to try these. So let's go back to our code. And Oh yeah, we have Microsoft and Apple from before. So let's just try that. So run all. Okay, so for Microsoft and Apple, we appear to lose money. Okay, so, right, this is not going to work all the time. And so see if you just, if you did buy and hold, you would have made a lot of money. But if you use this pairs trading strategy, you would have lost a lot of money. Okay, so now let's try what ChatGPT suggested. So tickers equals, was it Visa and MasterCard? Okay, so again, this ends up losing money. But at least this looks nice, you know. It has this mean reverting spread. It's just that the algorithm doesn't work that well. Okay. So now let's try, what was the next one? Procter & Gamble, Johnson & Johnson. Okay, PG. And Johnson & Johnson. Okay, so let's have a look. So again, we lose money. So apparently this strategy is not so great. It seemed to work well for our first pair, Coca-Cola and Pepsi, but not so well on these others. And also, I mean, we don't know. We haven't computed the correlation between these assets that we're trying. So that's something you'd want to do as well. And what was after this? TNT and Verizon. It is T, right? Yeah. Okay. Okay, so this also loses money. But I mean, AT&T and Verizon also lost money during this period. And you can see that the algorithm actually outperformed buy and hold most of the time. So if you quit here, you would have made money. Okay, but also, I mean, recognize that this also depends on the time period we run this on. And, you know, obviously I'm not going to try every single time period possible in these lectures because that would be a waste of time. But feel free to try other time periods on your own. Oh, and another pair I think that we'd want to try, it's pretty obvious that we want to try this, is Bitcoin and Ethereum. Okay, so let's run that. And this loses a lot of money. Okay, so over 100%. Well, then again, these are logarithmic returns, so they don't necessarily translate directly to cumulative returns. Okay, and it does sadly underperform buy and hold. Okay, so in this lecture, I want to discuss the concept of the long-only strategy. Okay, so that's long only. Okay, and so why do I like this? So, I mean, if you have experience with actual trading in real life, you know that if you want to be able to short sell, you need a margin account, your bank has to approve it, and all that kind of stuff. So I would say most people don't do that. And so long only is a more practical strategy for most people. Okay, and so it still makes sense. And what I want to do in this lecture is I want to show you that it still makes sense. So let's let's assume we have a mean reverting strategy. Okay, so or a mean reverting signal. Okay, so just something like that. And also, I should mention, we did learn this in the financial engineering course, but short selling is generally more risky. Okay, we've shown quantitatively using real data that because your estimates of the future are never accurate, short selling is more risky. And one of the practical reasons that short selling is risky is because let's say you short sell, or let's say you long, okay? Let's say you long and the stock goes from whatever it is down to zero. Okay, so in that case, you lose all your money. Okay, but if you short sell, so there's a floor here. The price of the stock can't go below zero. Okay, but what happens if you short sell and the stock goes up? There's no limit to how much it can go up. Okay, so you can lose much more by short selling, potentially. Okay, so that's another reason why you might want to go long only. Okay, so now suppose that using this signal, and you know what, I don't even like this signal. Let's use another one. So let's say, it goes down here, and then it goes up here, and then it goes maybe down there. Okay, so what are we doing if we go long only? And let's say the Bollinger Band is something like this. Okay, so in this case, here is where we would decide to go long. So we go long from here because you went below the Bollinger Band all the way up to here. Okay, so that's where we go above. And now instead of short selling here, we just sell. Okay, so if we sell here, then our money stays constant. Okay, whereas if you did a short sell here, then you would have earned some from this. Okay, so that's the only difference between short selling and not short selling. Okay, so instead of short selling, we just sell and our money stays constant in this period. Okay, and also to mention what it's going to look like in the code. So in the code, we have a -1 for short sell, but we have a 0 for do nothing. In other words, we close our long position. Okay, so close position. Okay, so in this lecture, we're going to explore how the long-only strategy performs. Okay, so we'll put that code into here. So long-only. And so what we're going to do is we're going to take asset 1 position, and we're going to say anywhere it's less than 0, which is basically where it's -1. We're just going to set those positions to 0. And we're going to do the same thing for asset 2. Okay, and before I run this, just to give you a little refresher in case you forgot how our algorithm was performing when we did use short selling. So you recall that we were losing quite a bit of money on certain pairs. Okay, I don't remember what asset this was. Well, I guess it's still up here. Yeah, Bitcoin and Ethereum. Okay, so let's go back up and let's try, well, let's use the same one we were just saw because then we can compare directly. Okay, so run all. And so look at that. So now we are no longer in the red. Okay. And do we beat buy and hold? No. But at least we didn't lose money. Right? So we're doing much better than before with long only than with short selling. Okay, so now let's try. So you recall that we basically lost money for all of these pairs, I believe, if I remember correctly. So that's what we're trying to avoid, if we can. Okay, so this one, we're still losing money, but we are not losing as much money as if we would have if we did buy and hold. So here we would have gained a bit. Okay. So now let's try PG and Johnson & Johnson. Okay, so again, we are no longer losing money using this algorithm. And how does it perform? But it underperforms buy and hold. Okay, and also, you can't really see it here. Well, we'll just look at it in the next one. Okay, so we have Visa and MasterCard. Okay, so again, it slightly beats buy and hold, but is this worth it to put in all this effort if you can just buy and hold and get almost the same return? I don't think so. Okay, now let's check Microsoft and Apple. Okay, so it looks like we're making quite a bit of money, but let's compare against the benchmarks. Okay, so it seems to perform about the same as asset 1, but it's outperforms by buy and hold for asset 2. I guess that's Apple. And so now let's try our original pair, Coca-Cola and Pepsi. Okay. Now, if you recall, when we ran this earlier, with short selling, we got about 40% increase. Now we're getting about 60% increase. So in this case, it turns out the long-only strategy performs much better. And overall, I think we found that for all these pairs, the long-only strategy performs better. Okay, so this shows that, in theory, you might think short selling will increase your returns, but in practice, that's not necessarily the case. Okay, and so this is pretty common in finance, actually. As we learned in the financial engineering course, it's quite common to limit the amount of exposure you have to any one asset, even though theoretically, portfolio optimization might say, put 50% into this asset. You might have as a constraint, always stay at or below 10%. And the reason that is because the theoretical calculation doesn't necessarily reflect the returns you'll get in the real world. Okay, so in this lecture, we're going to take a very quick look at the change that we made to use percent returns so that we could add them to get the portfolio return. Okay, so I did that right here. So we have asset position at time t minus 1, so shifted, times asset 1 returns, plus asset 2 position shifted, times asset 2 returns. Okay, and so when we compute the cumulative return now, how we do that is we no longer add, but we're using the formula you learned about earlier in the theory lectures, where we do the cumulative product of the gross return, so the return plus 1. Okay, and so this part's kind of optional, so we subtract 1 at the end, which gives us a percent return instead of a gross return. Okay, so but obviously that's just a plus 1 or minus 1 difference. So what you get when you subtract 1 is the base value is 0. Okay? And so this is for Coca-Cola and Pepsi. So you can see the return is a little bit higher now. Before it was around 0.6. Now it's about 0.8. And this is because if you did, let's say, add 1 to 0.8 and then take the log, it would become smaller. Okay? Because the log grows more slowly than the linear function. Okay, so but other than that, I mean, the results are going to change a little bit, but not that much. Okay, so in this lecture, we're going to do a sanity check to make sure that this concept that we've been talking about in this course really works. Okay, so I understand, if you've been looking at the results of the previous lectures, that you might be a bit suspicious that, does this pairs trading strategy really work? Did we make a mistake? Is there something fundamentally wrong with what we've done? Okay, and so I think it's always a good idea with trading and also with, when you're just studying machine learning algorithms. This is the way that we verify that they work. Okay, so typically we'd test a machine learning algorithm on a bunch of synthetic data sets to see how it behaves on a data set we know and we can understand. Actually, I think a great example of this, since we're in the browser right now, there's a page I like on the scikit-learn documentation where they just do a bunch of clustering examples. Yeah, here it is. Okay, so you can see that, this is how we do things in machine learning, right? We make up a bunch of synthetic data sets and see how our algorithms perform on those data sets. Yeah, it's the same thing. Okay, so you get the idea about why we want to do this. Okay, so going back to our mean reversion script. So first we're going to test a mean reversion just to make sure that this makes sense as a concept. And then we're going to go into tube assets for full pairs trading. Okay, so we'll begin by importing NumPy, pandas, and matplotlib. We don't really need pandas, but I just copied and pasted it from a previous script. Okay, so the next step is to generate our random signal. So you'll need to know a little bit about time series analysis in order to understand why this is a mean reverting signal, but you can just trust me that it is. And if you want to learn more, please check out extrareading.txt, where I've provided resources where you can learn this stuff if you like. Okay, so I'll try to explain what's happening here. So basically, we're creating an ARIMA model, or just an AR model, actually, an AR1 model, which means an auto-regressive model of order 1, meaning that the next value in the time series always depends on just the previous value in the time series. Okay, and so in order to initialize this time series, we need to create an initial value, which we'll call x naught. And for reasons you probably won't understand yet, this value is set to 1 divided by 1 minus 0.9. Okay, so you'll notice that 0.9 is our coefficient for this equation. Okay, and so we'll also create a standard deviation equal to 1, and we'll initialize a data array holding just x naught to begin. Okay, and then we'll loop through 300 steps, and then inside this loop, so we'll check if time step is equal to 0. If it's equal to 0, then the last value is x naught. And if it's not equal to 0, then the last value is just x. Okay, so you can see how we assign to x the expression 1 plus 0.9 times the previous value of x plus a randomly generated number, which comes from the random normal with mean 0 and variance sigma squared, which is just 1. Okay, and at the end of the loop, we append x, the new x, to our data array. Okay, and so my claim is that this is a mean reverting signal. So let's have a look, see what it looks like. Okay, so as you can see, this is pretty much mean reverting. And you can also see how this simulates what a stock price might look like, right? It goes up sometimes, it goes down sometimes. But unlike some stocks like, say, the S&P, there's no drift, so it's not always going up. Okay, and so the next step is to convert our data NumPy array. Oh, no, it's not a NumPy array, it's a list. We're going to convert that into a series. And then we're going to standardize the series. Okay, so for this example, we're going to ignore the fact that we should really be using only past values to compute the mean and standard deviation, right? This is just a first sanity check. And you can always change this later on if you choose. Okay, so this is Z. So Z is just the same series, but standardized. Okay, so the next step is to compute the rolling mean and the rolling standard deviation, which will give us the upper and lower bound. Okay, that's the Bollinger Bands. So let's run this. And you recall that it's the mean plus or minus 2 standard deviations. Okay, and so just to get an idea of what that looks like, we're going to plot everything. So we're going to plot the original series, which is Z, the mean, which is Z mean, and the upper and lower bound. Okay, so that's what that looks like. So you can see here, in the beginning, we don't have a rolling mean because these are just the first 30 values. But if we did, this would probably be below the red line. So the first trading signal is probably somewhere around here, where we go above the upper bound. So that's where we would short. And then we would go down. And then this is probably below the red line. So then we would go long, hoping it would go back up. And then it would go back up. And we're above the green line again. So we go short. And then we go down here. And then we go long again. And so on and so forth. Okay, so the next step is to compute the long signal and the short signal. So the way that we did before. So basically it's Z is less than lower bound, we go long. If Z is greater than upper bound, we go short. Okay. And so now we're going to make a really big plot of, what is this? So this is just overlaying what we had before. So Z mean, upper bound, lower bound, with the long and short signals, one on top of the other. So we can see how they relate. Okay, so this is the long and short signal. So if you can't read this, long is blue and short is orange. Yeah, you can always run this yourself using the provided code for this course. Okay, so as mentioned, the first signal is right here where we go above the green, so we go short. So that's where the orange goes up. And then, so apparently this doesn't go below the red, but we do go below the red over here. So that's where we set the long signal on. And then over here we go above green, so we go short again. And then it goes above green again and again, so we stay short, essentially. Now, you recall that there was a point where we did extend this signal. In this lecture, I believe we're going to try both. So let's continue on by setting the position signal. So as you recall, position, since we only have one asset, so we did this example earlier in the course where we did a simplified pairs trading algorithm where we just set the second asset to 0 all the time. Okay, so this is equivalent to that, where we have one asset, but we're technically doing pairs trading where the second asset is just 0. So the position on the first asset is still long minus short, okay? And what are we doing here? So we're plotting the same time series again with the Bollinger Bands, and now we're just plotting the position instead of long and short. Okay, so here is position, and you can see where we had short before, now it's -1, and where we had long before, it's +1. Otherwise, it's 0. Okay, and we're not going to extend the trading signal yet, because in this lecture, we want to test both. So the next step is to compute the cumulative return. So you recall we do that by shifting the position up by 1 and then multiplying it by the percent change of the price, which is the simple return. Okay, and then we're going to also plot these daily returns as well. So notice how when you use this type of strategy where you don't extend the signal, you only get a return once every so often, right? Otherwise, your position is 0, which means you're just holding cash and you're doing nothing. So that's what the daily return looks like when you don't extend the long and short signals. Okay. So the next step is to compute the cumulative return. So you recall that earlier in the course, I talked about how to fill the NAs. And so with this daily return, the initial values are NA because earlier in the time series, we don't have any upper and lower bound, which means we don't know how we should be trading. So basically, we're just going to fill in those earlier values so that we can add 1, so that we can compute the cumulative product. Okay? And so notice how we're filling it with 0. So it becomes 0 plus 1, which is 1. And then 1 times 1 times 1 at the beginning will just be 1. So in other words, you're not gaining anything when you hold cash. Okay, so that's what that looks like. So you can see the return is positive. So by the end of this, we end up with about 45% more money than we started with. And so the next step is to see if we can improve this by filling in the positions. So that's what I referred to earlier as extending the signal. Okay. So you recall this code from earlier. So we take the position filled, which is a copy of the original position, and then we look for all the 0 values, set those to NaN so that we can call the forward fill function, which just takes the previous value and fills it forward. So wherever there was a 0 before, now it's going to be either +1 or -1, depending on what came before. Okay, so let's just plot this position filled variable to see what it looks like. Okay, so you can see here that we start off at -1, then we go to +1, then -1, +1, -1. So importantly, notice that the number here, it starts at somewhere below 50, which is probably around 30, which is because we don't have values at the beginning, right? So we can't forward fill at the beginning since we converted all those values to NaNs. Okay, so let's plot the head of this position filled, and you can see how the first 41 values are NaNs. Okay. And so here we're going to plot the position again against the original time series. I think this one doesn't add up because it starts at 50, whereas the time series itself starts at 0. So you can fix that as an exercise if you like. Yeah, so just notice that these time series don't line up because the first few values are NaNs for the position. Okay, so now we're going to compute the cumulative return again. So we'll call this one daily return 2, and it's computed from position filled instead of position. And we'll also plot the return. Okay, so this is the daily return. Notice how it's much more up and down than before. So before, we had just a bunch of little spikes, and then the rest of the time it was 0. Whereas here, now we have a bunch of squiggly lines, which means we're getting a return every single day. Okay, and so notice how, again, this starts at around 40, time step 40. And so when I was running this, I wasn't sure, so I just did a df.head again, just to check whether it really did start with NaNs. Okay. And so here it becomes important. I don't think it was important before because it was already 0. But now that we have NAs, we're going to fill them with zeros and then add 1 and then do the cumulative product. Otherwise, we would just have NaNs. Okay, so here we have cumulative return 2. So you can see when we start, it starts out just being 1 all the time because that's just the equivalent of holding cash and not investing, not taking a long or short position. Okay, So the next step is to now compare the two strategies. So the mean reversion strategy without holding, without extending the position, and then the mean reverting strategy with extending the position. And then we're going to compare it with buy and hold. So in this case, buy and hold should return 0 because it's a mean reverting strategy. So we always expect the price to just fluctuate around the same mean, which means the expected price is always the same price. Okay. So let's look at this. Okay, so just in case you can't see the chart, the orange line is the performance of the strategy where we extend the position. The blue line is the performance of the strategy where we don't extend the position. And then the green line is the original time series, so that mean reverting price. And you can see for this particular example, the full strategy where we extend the signal actually underperforms green, underperforms buy and hold. And blue seems to actually result in approximately the same return. Okay. Now I'll tell you right now, this is really a fluke. This didn't happen most times I ran this when I was testing it out. But we'll continue anyway. Okay, so there's more. So, right, so above, you recall that we didn't standardize Z correctly, right? We used the whole mean and the whole standard deviation. This time we're using the rolling mean and the rolling standard deviation. Okay, so basically we're just going to do all the same work again, but with the rolling mean and standard deviation from the original series. Okay, so again, we compute the upper and lower bound. And again, we plot the Bollinger Bands with the original standardized series. And it looks about the same, I think, which is good, which means that not cheating and using the future values to compute the mean and standard deviation doesn't matter so much. Okay, then we have long and short signal. And then we plot the signals with the time series to see where we are trading. Okay, so that seems to make sense. Does it? It's good enough for me. You can look into it if you want. Okay, so I see what's weird about this. So basically, the timescales are again different. So here's 50 for the top graph, but here's 50 for the bottom graph. And the reason that is because our standardized series, it no longer has the initial values because it's computed from the rolling mean and standard deviation from up here. Okay, so that's fine. It doesn't matter. Okay, so then we compute the position, and then we plot the position against the time series again. Okay, so this time I made them line up. So I used plt.xlim. Okay, so now they line up, and you can see that this starts over here, away from 0. And now the moving average starts even later. Okay, and so now we're going to compute the daily return again. Okay, and it's basically the same pattern. Then we do the cumulative return. Okay, same thing. So notice how when we standardize correctly, the performance of the algorithm is different. So now we appear to be losing a little bit of money. And so again, we extend the signal, extend the position, and we plot the position again against the original time series. And again, we compute the daily return with the extended position. And so again, it's just the squiggly lines and cumulative return for the extended position. Okay, so we lose a bunch of money. That's fine. And then we plot the performance to compare the three strategies. Okay, so buy and hold wins. Strategy without extending the position loses a little bit of money, and then strategy with extending the position loses a lot of money. Okay, and what else do we have here? It has a bunch of just debugging stuff. Okay, so let's go back up. Let's run everything again from here, just to test out how well does this work on average. Okay, so again, we have a mean reverting signal. Okay, and when we do cheat and use the future values to compute the mean and standard deviation, so this is how we perform. So this is the typical chart that I saw. So when you do extend the signal, you do much better. So that's the orange. When you don't extend the signal, you just see those flat lines. But you do improve a little bit. And then the mean reverting signal, that just hovers around the mean, whatever that is, 0, 1. Okay. And then the second chart is the one where we don't cheat by using future values. And so for this as well, we outperform most of the time, but at the end, the performance starts to decrease. But it still does perform better than both buy and hold and without extending the position. Okay, so let's go back up. Let's try it again. Okay, so another mean reverting signal. Okay, so here's the performance of, I should have told you guys the colors earlier, but it's fine. So orange is the performance of the strategy with extension, blue is the performance of the strategy without extension, and then green is the original price signal. So again, orange performs the best as expected. So if we go to the second example where we compute the rolling statistics, performance is about the same. So orange outperforms as usual. Okay, but it does have a lot more variation and risk, so that might not be good. Okay, so let's run this one more time. Okay, so here's the time series. Okay, and so this time, the algorithm performance is so good, you can't even see the green and blue lines. They basically just look like noise. Okay, so according to this, you would have multiplied your money by about 25 times. And so this is with the rolling statistics. Okay, so in this case, with the rolling statistics, so I guess that's why you have to be careful that you compute your statistics correctly. This actually underperforms buy and hold. Okay, so let's run this one more time, just because I'm curious. Okay, that's the signal. Okay, so this is the performance with computing statistics from the future. And then here's the performance of the algorithm when you compute using the rolling mean and standard deviation. So again, look at how orange performs a lot better than both green and blue. Okay, so in this lecture, we're going to continue looking at synthetic data. And this lecture will look at full pairs trading. Okay, so the previous lecture looked at just mean reversion by itself to make sure that that made sense. And now we're going to look at two assets. Okay, so we'll begin by importing NumPy, pandas, and matplotlib. Again, we don't need pandas because we're just creating our own data, but it's fine. And so the next step is to set a random seed. So the reason I did this is because the algorithm is quite sensitive. And so I wanted to show you different cases, different scenarios to see where does pairs trading succeed and where does it fail. Okay, so the next step is to generate our mean reverting signal again. So we're not going to use this. We're not going to consider this as the price, but we will use it to generate our actual prices, right? Because basically the difference is supposed to be mean reverting. So we're kind of doing it backwards, where we're generating the difference first and then generating the prices from this difference. Okay. So you can see here, I am generating the prices, which I've called P, and then we're storing it in a list called asset one. So if you haven't seen this before, either from my financial engineering course or my time series analysis course, what this is doing is it's generating a random walk. And so what is a random walk? And why is that relevant? So a random walk is basically you take the previous value and you just add random noise, in this case from a random normal with variance sigma squared and mean 0. And that becomes the next price. And then the next price again becomes the old value plus more random noise. And so why is this a good model of a stock price? And the answer is that it shares some statistics like the ACF and the PACF that we computed from real stock prices in those previous courses. So if you watch those previous courses, then you understand why this is a good model. If you don't, maybe go read about random walks. Okay, but either way, this is a good model for the price. And so the next step is to create the prices for asset 2, which is basically just going to be the prices for asset 1 plus this mean reverting signal, which is meant to be the difference, right? So the difference is actually this minus this. Right, so if you thought about this like a mathematical equation, you could bring this one to the other side, this one to this side, and then you'd have asset 2 minus asset 1, and that's equal to this mean reverting signal. Okay, so the next step is to convert these into pandas series. Okay, so I guess we do need pandas, right? Just because I wanted to use the same code from earlier. Okay, and so the next step is to make a plot of the two series. So you can see that they generally have the same shape, which is what we're looking for. And so here I've subtracted basically the mean of asset 2, or the mean of the difference from asset 2, so that they line up. Okay, so you can see that the changes between the two assets are very small compared to the change in the price itself, which is going to come into play later in this lecture. Okay. And so now we're just basically going to go through the same pairs trading code that you've been looking at throughout this course. So we compute the mean, the rolling mean and standard deviation for all of the assets. And we use that to standardize the two prices, right? Just want them to be on the same scale. So Z1 and Z2 are now standardized. And also notice that they both have the same variance. I could have changed this as well, but I didn't bother to. So you might want to try that yourself as an exercise. And hopefully by dividing by the standard deviation, they still go back to the same scale. Okay, so the next step is to compute the spread. So that's just Z1 minus Z2. And so notice how we now have this nice mean reverting signal. And the next step is to compute the rolling mean and standard deviation. And this is for the Bollinger Bands. Okay, so the upper bound is the rolling mean plus 2 standard deviations, and the lower bound is the rolling mean minus 2 standard deviations. Okay, so the next step is to just plot the original spread with the upper and lower bounds so we get some idea of where we are going to do our trades. Okay, so we see it goes above here and maybe there. Okay, and then we have our long and short signal computed the same as before. And then we compute our positions, which is so long minus short and short minus long, as you recall. And I've also left in a comment here. So you can try the wrong way, which was originally proposed by ChatGPT, which was short minus long for asset 1 and then long minus short for asset 2. So you'll see how that performs as well if you choose to uncomment this. Okay, so the next step is to plot the positions on the same chart as the spread with the Bollinger Bands. Okay, so yeah, so again, I didn't bother to make these line up, but you could do that as an exercise. Okay, so the next step is to compute the cumulative return of the strategy. Okay, so to do that, we compute the returns for both asset 1 and asset 2, and then we compute the daily return, which is asset 1 shifted by 1 times asset returns, plus asset 2 position shifted by 1 times asset 2 returns. And then we're going to plot the daily return. Okay, so again, we just have these little spikes because this is with the long and short signals not extended. Okay, and so again, same computation as before for the cumulative return. Okay, so we get about 8% return. Okay, and so the next step is to extend the positions for both position 1, which is for asset 1, and position 2, which is for asset 2. And we also plot them at the end. Okay, so here's our extended positions. And here's the daily return of the strategy. Okay, so it looks like noise, but hopefully it goes up overall. Okay, so here's the cumulative return for the extended position. Okay, so now we get 25% return. And so here we're going to now compare the two strategies with buy and hold for the two assets. Okay, so again, just in case you can't read the text because it's too small, orange is the performance of the strategy where we do extend the positions. Blue is the performance of the strategy where we don't extend the positions. And then green and red are the prices of the original assets, normalized to start from 1. Okay, so you can see how the strategy at first, it underperforms, and then later on, it outperforms. Okay, and so this is the general pattern we'll see. So if buy and hold is doing well, the strategy is not doing that well. But if the price goes down, I find that the strategy tends to perform okay during that time. Okay, so let's go back up and let's try the other cases. So here is random seed 16. What did I say here? Overperforms even when stocks perform poorly. Yeah, so basically that's just what we saw earlier in the second part. Except that for this, for these assets, they just go pretty much down all the time. And so the strategy performs okay. And it definitely performs better than not extending the signal, not extending the position. Okay, and so let's go back up again and let's try the third case. And this is the case where buy and hold is going to win. Okay, so here's the difference. Here are the prices. Okay, and here is so orange again, that's the strategy with extending the position. Blue is the strategy without extending the position, and green and red are the original prices. So notice that this performs really well, whereas the strategies, both of them, don't perform well. And so we can try to understand how this occurs and why this occurs. So basically, this pairs trading strategy, what it's trading on is not the overall movement of the two assets. It's trading on the differences. Okay, and so suppose that those differences are not that great. Okay, so if we go back up and we compare these two prices plotted side by side, those differences don't occur very often. So basically what's happening is just the price itself is going up so often that simple buy and hold outperforms any strategy where you try to take advantage of these little differences, because those little differences compared to the overall increase is very small. Okay, and so how does that relate to the stock market itself? Well, I mean, in the stock market, generally speaking, let's say we treat the S&P 500 as the market, it's generally always going up. And so if you try to do pairs trading with something that's always generally going up like this, we've learned maybe that's not such a good idea. Okay, so maybe in those cases, it's better to just buy and hold. Okay, so in this lecture, we're going to conclude the course and talk about the lessons we learned. Okay, so the first thing I think we all notice is that ChatGPT is very useful. Personally, I probably wouldn't even have bothered to do this myself, right? It's only because of ChatGPT that I got this idea to take on this project and to make this course. So it really is making us more productive and efficient. Now, the second thing to be aware of is that ChatGPT does make mistakes, and we've seen this really many times throughout the course. So ChatGPT is not a substitute for competence. What it can do is it can enhance your competence. Okay, so if you are competent, it can make you better. But if you are incompetent and you don't know something, it won't necessarily make you more knowledgeable. Okay, so basically what would happen if you asked it for code is that you just wouldn't notice the mistakes that it made. And so what's going to happen in your work is that you're going to go from putting out some bad code to putting out just more bad code because you're not checking what ChatGPT gives you. While at the same time, it's just helping you write that code faster. And sadly, I've already seen examples of this where people just assume that AI is right and therefore they become more confident about the bad code they've produced. They say, well, an AI produced this, how could it be bad? Well, the answer is, it's bad if you didn't check that it's correct. And that's not to say that I didn't make any mistakes or catch all of ChatGPT's mistakes in this course. I really just did this course for fun. And based on these preliminary results from what we saw with the pairs trading performance, I personally wouldn't investigate this algorithm further. But if I did want to, I would have to take it seriously and make sure that there are no mistakes. So I would do further checking if that were the case. So now, kind of a funny corollary to this is that people think that if AI can't do something, that the task must be impossible. And so the punchline is the student that actually did this, this was for an exercise in my easiest free course, the NumPy stack. So, I mean, among all of the exercises that this student could have tried, this was the easiest one. And in actuality, the problem was more likely that the student couldn't articulate the exercise correctly, right? So if you want ChatGPT to do something, you have to use the right words, the right prompt, in order to get it to do what you want. Okay, so one important thing to keep in mind is to not conflate these two orthogonal issues, right? There are really two themes of this course, right? One theme is exploring ChatGPT, and the other theme is finance and pairs trading. So I don't want you to conflate these two things. Okay, so one aspect of this course is ChatGPT's abilities, which we've seen are quite good. Okay, but the number 2 issue is the performance of pairs trading. Okay, so how well pairs trading performs doesn't have anything to do with how good ChatGPT is, right? If you implement a suboptimal strategy perfectly, it's still going to perform suboptimally. Okay, that has to do with the strategy itself, not how good ChatGPT is at generating code. Now, on the other hand, you might have a great strategy, but ChatGPT might make mistakes in its implementation, so you need to watch out for that too. Okay, and you need to watch out for the case where both of these issues might be happening at the same time. So you might have a suboptimal strategy, and ChatGPT is giving you code that has mistakes that you need to fix. Okay, so you really need to be on your toes and figure out where these issues are coming from. Is it coming from a mistake that ChatGPT made in its code, or is it coming from the fact that the strategy just doesn't work that well? Okay, so you have to know how to attribute the performance of your code to one or the other. Is it ChatGPT's fault for making a mistake, or is it the strategy's fault for just not being that good? Okay, and finally, I want to say to the students of this course, please share your ideas with the rest of us. I'm sure many of us would be interested in what you're doing and what you can come up with. So if you've used ChatGPT to develop different trading algorithms, or even if you've used ChatGPT for the same algorithm, pairs trading, but got a different answer, I think we'd love to see what you've generated. And if there's anything else you've asked ChatGPT to do that you think is interesting, whatever that may be, please share it with us. Right? Because I think that one important aspect of interacting with these large language models that goes overlooked is creativity. Right? Because there's so much you can do, and it really depends on what you think of to ask ChatGPT. And for that reason, because there are so many of us taking this course, I think it'd be really interesting to see what we can come up with. Okay, so I hope you had a lot of fun playing with ChatGPT. I hope you had a lot of fun taking this course, and I hope you learned something useful. Finally, I want to thank you for taking your time to go through this course, and I'll see you in the next one. Take care. Okay, so I got this idea to ask ChatGPT if it knows who the lazy programmer is. So if it knows who I am. And this is the answer it gave me. Who's the lazy programmer? So there is no one definitive lazy programmer, as this term can refer to a general attitude or approach towards programming rather than a specific individual. In general, the term lazy programmer can refer to someone who values efficiency and automation, true, and seeks to minimize the amount of manual work they have to do by writing scripts or programs to automate repetitive or time-consuming tasks, true. This approach can be very effective in many contexts, especially in software development, where automating certain tasks can save a great deal of time and effort. However, it is important to note, typical ChatGPT thing to say, that the term lazy programmer is often used humorously or ironically, and should not be taken to mean that the individual in question is actually lazy or unproductive. True. In fact, many highly skilled programmers adopt this approach as a way to maximize their productivity and achieve better results. Okay, but here's the interesting thing. If we ask ChatGPT, tell me about the courses created by the lazy programmer, now it knows who I am. So it says, the lazy programmer, also known as lazy programmer camel case, on various online learning platforms, has created a wide range of courses primarily focused on data science, machine learning, and artificial intelligence. Here are some of the most popular courses created by the lazy programmer. Okay, so here's where it starts to get strange. So it says, number 1, Data Science and Machine Learning Bootcamp with Python. So I actually don't have any such course. But it says this fictitious course, what it's about is this is a comprehensive course that covers all aspects of data science and machine learning, including data analysis, data visualization, supervised and unsupervised learning algorithms, and deep learning techniques. Well, I suppose if I made a course called this, that's what it would be about, but I have no such course. Now, the other courses it does get correct. So let's look at number 2. It says Deep Learning Prerequisites, the NumPy Stack in Python. So I do have a course called this. Now, what it says it's about, it says, this course is designed for individuals who want to learn the fundamentals of deep learning, including neural networks, backpropagation, and gradient descent. This course focuses on using the NumPy library in Python for implementing these concepts. So that's actually false. That's not what this course is about. Okay, so the number 3 course is Artificial Intelligence, Reinforcement Learning in Python. And again, this is a real course. But it says, this course is dedicated to the study of reinforcement learning and its application in various fields such as robotics, game development, and finance. The course covers various RL algorithms, including Q-learning and policy gradient methods. Okay, so it's partially correct. It does cover Q-learning. It does not cover policy gradient methods. And it does do a little finance project. Not really game development. I mean, we do tic-tac-toe, which is kind of a very simple game, but nothing like today's games. And we don't really discuss robotics. Okay, so I'd say it's like 30% correct. Okay, so then we have Cluster Analysis and Unsupervised Machine Learning in Python. I believe that's the name of the course. Something like that. Anyway, it says this course covers unsupervised learning algorithms, including clustering and dimensionality reduction techniques. False. This course also focuses on real-world applications of these algorithms in image and text processing. Okay, so the only thing wrong with this course is only about clustering, not dimensionality reduction. Okay, but other than that, do we cover image and text processing? Kind of. I believe we have an NLP example and maybe an image example. I'm not sure at this point. Okay, so the next course is Bayesian Machine Learning in Python. So this is kind of like a partial title. But I guess at the time ChatGPT was trained, I did only have one course called Bayesian Machine Learning in Python A/B test. So it's kind of correct. And it says this course teaches Bayesian machine learning concepts and techniques, including Bayesian networks, Bayesian linear regression, and Markov chain Monte Carlo methods. Okay, so this is only partially correct. This course does not cover Bayesian networks, nor Bayesian linear regression, nor Markov chain Monte Carlo. But obviously it does talk about Bayesian machine learning techniques. Okay, and so the last course is Advanced AI Deep Reinforcement Learning in Python. This course provides an advanced study of reinforcement learning, including deep reinforcement learning techniques and algorithms such as deep Q networks, A2C, and TRPO. Okay, so again, only partially correct. So it does cover deep Q networks. It does not cover A2C, it covers A3C. A2C is in the sequel to this course, and TRPO hasn't been covered at all. Okay, so basically, again, it's kind of making stuff up. Okay, so it concludes, as every ChatGPT article does, says, overall, the Lazy Programmer's courses are designed to be beginner-friendly, but also provide a comprehensive and deep understanding of the topics covered. The courses are also highly practical, with many examples and projects included, which helps students gain hands-on experience and develop a portfolio of work to showcase their skills to potential employers. And yeah, that's pretty much true. Okay, so I think the lesson here, other than the fact that the lazy programmer may have an overinflated ego, is that you should not trust what ChatGPT says. So consider what people commonly use ChatGPT for, usually for doing or writing about things they themselves don't know about. And this is because, well, if you already know about something, you'll probably just write it down yourself. But if you don't know about something, then you might think, well, if I don't know about something, well, then let me get an expert like ChatGPT to do this for me. And you might think ChatGPT is awesome because it knows more than me. But you forget this important fact, which is that if you don't know about something, then anything that anyone says will sound good and they will sound like true facts. In other words, if you are incompetent about a subject, ChatGPT is going to seem competent because it knows more than you. Of course, the danger is ChatGPT is just making stuff up. And if you are incompetent and you don't know anything, then you can't tell the difference. Okay, so hopefully this lesson is clear. If you are incompetent about a subject, you can't tell the difference between true and untrue facts. And the sad part is I'm already seeing this with some students. So I'll give them exercises that they can't solve by themselves, so they'll ask ChatGPT, and either ChatGPT can't solve it or tells them something very generic and sometimes factually wrong. And they believe it's right because they don't know any better. So I've seen one example where ChatGPT couldn't solve the exercise that the student gave them. And so they assumed that, this exercise must be impossible to complete. But in that case, it was probably because the student just couldn't come up with the correct prompt. In other words, they couldn't even phrase the exercise correctly in language. Okay, so that's not a failure of ChatGPT, that's a failure of the student, where they weren't even able to express the idea in language. So basically the danger is people are already starting to believe that because something was written by an AI, it must already be superior to human knowledge. Okay, and as we've seen in this lecture, I hope this is a good demonstration that this is a mistake.